ठीक है. Good afternoon, people. My name is Sarthak. I'll be running the second workshop. I'm sure you would have enjoyed the first one. I hope to make it as interactive as possible. Few ground rules: no side conversations. Okay, one conversation at a time. Fair? No big deal. And keep your mobiles on mute. Okay? Ask questions. Ensure it is interactive. If something is not clear, we'll repeat as many times it is necessary. I'll try and avoid getting into rabbit hole of a topic T. I have to finish this workshop before 6 p.m. Fair? Okay. All of you have cloned the repo that was given to you, Rust Workshop Labs? Yes? It's a question with a Boolean answer, yes or no? Very good. People, take 2 minutes, clone this repo. You have Rust installed, right? Fair? Sure? Okay. I'll take that as a yes. For online participants, the link is on the Zoom chat. Good to start? People, I would appreciate a response. Yes, no. Good to start? Cool. ठीक है. We have a lot to cover. I'll try my best to cover as much as I can. Okay. I'll tell you the overall idea behind this workshop. What we are going to do is build a simple in-memory cache, which is thread safe. Fair? It will be a simple in-memory cache which will be thread safe. That means it will be accessible by multiple threads in or concurrency. Okay? Fair. Let's start with a very, very simple idea. We have multiple modules. I call them as stages that we have to go through in this workshop. We'll go one by one. We'll not jump the stage. We'll skip a stage if I tell we have to skip. Okay? The first step is a very, very simple cache, which is just a wrapper over HashMap. Do you see this? What do you see? Come on, speak up. People, speak up. Louder. Turn it on if it's not. Fair. It's a simple struct. Everybody recognizes it. No problems. Struct is named cache. Fair. It has an element data, which is a hash map. Hash map is a key value data structure. What is the data type of key here? String. What is the data type of value? Simplest cache you will ever see. Great. Now, before we get to references, there is something that I want to touch on. How many of you from non-Rust backgrounds? Nice. Very good. How many of you from, let's say Java, Python, Go? These are from Python. Huh? Very nice. Some from Java also? Cool. Nice. In Java, when you say I'm passing a string from one function to another, what happens? One, the copy of the string is passed, or a reference of the string is passed. Which of these two happens? Same in Python. Everything is object in Python, someone is saying, okay. So, everywhere it is reference. So, may I know your name? Bhuvneshwar. So, he's saying in Python, when you pass an object from one method, one function to another, it is passed by reference. What does that mean? In heap, the object is allocated somewhere. Agreed? Yes, no? साला सारा मेरे को ही बोलने का है क्या? Right? You have an allocation somewhere in heap. When you pass that object to some other function, the reference count is incremented. Agreed? Which means languages like Python, Java, Go need a mechanism to decrement the reference count and clean that object when the reference count goes to 0. Agreed? Okay. So you pass by reference. Okay? If you pass by reference, you can clean that up. The GC cannot clean that up, right? Agreed? So if I have a string, I pass it to another function and GC cleans up, then the other function to which I had given the string is working on a memory which is cleaned up. That's not making any sense, right? So languages like Python, Go, Java rely on something called as GC because their foundation is reference counting for every value type or most of the value types, ignoring the primitives. Yes, no? Okay. Okay. So in Rust, we have you can have owned values or you can have borrows. Still visible? Okay. You have array list in Java. I think Python has list. Nice. Golang has a slice array. Okay. It's a collection of values, right? And it is dynamically growing data type. Yes? Which means where will the allocation happen for these objects? Okay, heap, why can't it happen on stack? Let's talk for a minute. We are designing our own programming language. Both of us are pairing, okay? We want to have vector or an array list. I am telling you, hey, let's allocate it on stack. But you're saying, no, it has to go on heap. Why are you right and I'm wrong? Quickly. Size can vary. But that's okay, right? Even stacks have different data types with different sizes, right? That's fine, we'll handle it some other way. It's a design choice, okay.
While running after compilation, stack is continuous flow.
Even array list is contiguous, right? When you allocate memory for array list in Java, list in Python, you say, hey, I want an array of n bytes. 10 multiply, let's say I want an array list for 10 integers. Assuming integers are 4 bytes, give me 40 bytes of memory. That's what you're asking heap. Perfect. Stack can only have data types which are fixed in size. Sizes known at compile time. Perfect, right? So all of you are right. If you were designing your own language, a data type like vector, HashMap, array list is vector, will go on heap. Fair? What will be on stack? Pointer or a variable or a reference which points to that vector? Yes? Good so far? Nice. So, You have a vector in Rust, okay? Ignore the syntax. It is like your list of Python. That means we have V on stack, agreed? Yes, no? On heap, I have a vector, okay? Vector for, it is a contiguous memory. Each memory is holding, okay? Assuming it is I32. So 4 bytes, 4 bytes and 4 bytes. Make sense? Okay. On stack in Rust, size of V is 3 words. Pointer, length, capacity. On a 64-bit machine, this is good so far? Any questions? Now, vector is considered to be owning its elements. Vector owns the elements. That means, so we say vector owns its data. Okay? Which means when V goes out of scope, when V goes out of scope, the entire vector is dropped. There is no GC. Clear? Now, what does it mean to say vector owns its data? We were taking an example of string in Python and Java. When you're passing string, you're passing references of underlying language, right? In Rust, when you pass a vector, you're not passing a reference, you're moving the object. That means there is a function A, it has a vector V, I call B function passing this V. What does it mean? Am I passing a reference? No. Am I cloning the vector? No, I'm not cloning. I am giving the ownership of vector to B. I am telling B, take this vector, do whatever you want to do with this vector. I am not going to use V anymore. Okay, what does this mean? I will call B with V. Now use V here. This is compilation error. V is gone. Make sense? Question? This is not really reassignment. Literature-wise, we call it as move semantics. Someone from C++, right? What is moving a pointer? Do you want to explain? Yes. You give ownership to others. It will become clear as we move on. All I'm saying is, hey, I have a vector. See? You understand how vector is allocated? It's on heap. It owns the elements, right? I have a variable V on stack. It is a 3-word pointer. I am giving you my V. I am giving you a variable V which represents a vector. That means I am passing the ownership, right? I'm not copying it. I'm not cloning it because cloning is expensive. Copying will get there. I'm saying I will not be using V anymore. You take the V, you do whatever you want to do with it. If I try to access V, compiler will give me an error, the value is already moved.
Should I think of this as
No, there is a difference. In Java, null is a mistake, right? Fair?
So what is happening to the
Nothing. Compile time error. I'll show it to you. Let's do a quick test. I hope the screen is visible. It's a test which I'll delete in a while. Okay. So I've created a V. I've created a V which is a vector of strings. Clear? Nice. What's your name? Akash. You see the red ticks? Value used after being moved. Someone has taken the ownership of the value. Once the ownership is gone, value is gone. Which means, if we were to draw it pictorially, what has happened? What has happened? Let's try and see this. I had a V which was pointing to a vector in heap. This is my heap. Okay. Whatever. Good so far? I passed V, I gave away the ownership of V to a function called B. B said new V, which is a vector of I32 or whatever, doesn't matter. Now, new V is pointing to the same heap location. Clear? What happens to V? A compiler trick. Gone. New V is pointing to a valid location in memory. When new V goes out of scope, vector will be deallocated, dropped, right? But V, you cannot access V anymore. This is the start of ownership. Good so far? Now, this is owned values. What is a reference then? You folks were talking about references in Java, Python. Yahan pe, what if I don't want to give the ownership of vector? What would I do? I will say B. Let's say a variable Q. These are bad names. Where vector of I32. This is a syntax which means borrow it. I am giving you, what is the dictionary meaning of borrow? I will give it to you, but you promise me you will give it back. I am loaning it to you, right? You can't take a loan from me and never return. Makes sense, right? I am giving it to you. Udhar dena Hindi mein, right? I am loaning it to you. You give it back to me. This is called as a reference in Rust. We will only talk about shared reference. The syntax that you see at the bottom of the screen, right? It's a read-only reference. You can't mutate vector using just ampersand vector I32. Good so far? Yes, no? Okay. Now that you understand a bit, Explain the syntax to me, the syntax of get for me, quickly. Just get, huh? Go ahead, go ahead. Is the syntax clear? Look at get. I'm taking ampersand self for Pythonists. This is like this, right? But here it's a ampersand self. What does that mean? Which reference? Perfect. Which type of reference? Read only or mutable? Immutable or read only. See, ampersand self, it's a read-only reference. Ampersand T, it's a read-only reference. I cannot mutate taking this reference. Clear? Louder. Key, give me a borrowed string. Clear? Okay. And then do whatever you want to. Okay. Now explain me this. First signature, put. Louder. Mutable reference of cache. Why do I need mutable reference?
Because we want to put the value inside the data field value of that cache.
Mutable reference allows you to mutate your type T. It can be anything. Cache, HashMap, string, vector, whatever. In fact, even you can have a mutable reference to an integer, right? So perfect. Mutable reference to cache. Now, second argument.
The string, simple string and value of string.
Why not? Okay, that will be a little early.
Because
Keys.
the definition of the hash map is the string by string, not the reference by reference.
Perfect. HashMap owns its strings. Clear? What does this line mean? HashMap owns its strings. Huh? It is not a reference. That means when HashMap gets dropped, all its data gets dropped. When you pass string to HashMap, string will be gone inside the HashMap, right? Fair? Okay. We'll talk about mutable in more detail. Before moving on, I gave you an example of how vectors are allocated. Similarly, string is allocated on heap. Okay? Because string is a varying length data type. Okay? On stack, it is a 3-word pointer. Pointer, length and capacity. Clear? Okay. This is the ownership hierarchy that we talked about. Can you see the struct company? Company has employees. It is a vector of employee. Each employee has a name which is string. How would the hierarchy look like? On stack, company is nothing but a vector, agreed? Okay. Vector is a 3-word pointer, agreed? Okay, that is what stack is. On heap, the first element of vector is an employee, agreed? It is a name, okay. So the first element on heap, for now, let's just consider it as string. It is again a 3-word pointer because string is a 3-word pointer. And then you have finally heap, the memory for the heap, for the string. As soon as company goes out of scope, the entire hierarchy will be dropped. No GC. Clear? Okay. Now, in the repository that you've cloned, all you have to do is finish the first assignment. Start. People, open stage 1 cache.rs. You will see, the entire code is unimplemented. Okay. You have to implement put and get. While you implement, also try and read these comments. I think they should help you understand what is happening and question your mental model. Let me know once you're done. And please use an ID of your choice. It'll be easier. Done? Yeah.
So the put method actually return an option where for the entries got insert an ID. It said it return an option. Why would it wait?
We will come to that. Done, people? You have 1 minute 30 seconds left. Okay, people, let's try and do it together quickly. I'll remove unimplemented, if I could remove. Simple. All we are saying is, I already have a mutable reference. Mutable reference to what? To self. What is self? Cache, correct? That means I can mutate anything within the cache, agreed? Yes, no? Okay. That means entries is already a hash map, it gives me insert. Okay. How do I do get? I need a read-only reference, self.entries.get from the hash map. Now, question, repeat it for the audience.
Yeah, so my question is
Insert of hash map returns an option. It's not saying it will fail. It is saying either I'll give you none or some. Okay, what is option? Not failed. None means nothing, right? It's not failed. If you read the documentation, thank you. If you read the documentation, it says, I will give you a none if this key was not present. But if the key was already present and was being updated, I'll return you this, return you the old value. It is an option of V. Correct now? Now tell me, people, why am I returning option of reference of string? This question, who can answer quickly? HashMap owns the string. Okay. So, your name? Rajendra. Rajendra. Rajendra is saying HashMap owns the string, right? Which means HashMap has its data. You want the data, it can give you a reference of the string, right? It cannot return the entire string out. But what if I need the entire string? I don't need the reference. What would I do? With the limited knowledge that we have so far. First, if I were to return a string, let's say if the signature were this, good so far? I'm getting an option of reference of string. Okay. Done? HashMap had the reference. I need the value out. With the knowledge that we have so far, all I can do is clone, right? So I need to first check, hey, was the value actually present? And it's a syntax in Rust, if let and the enum variant, right? It's a pattern matching. If let enum variant and its value. If the value was present, you can see the ID is giving us the hint, reference of string. I will do a clone. Okay? And I will be able to return option of string. I still want to have option. Okay? Okay. I think all your tests should pass. You can also do cargo stage 1. The test will pass. Now tell me one thing. What is happening here? Quickly. I have a cache.
Yeah, I have a question here.
Yeah.
So, is it idiomatic for the map to give up ownership of the value query?
Map is not giving the ownership. We cloned the value. We still did not leak the value out. Map is not giving away the ownership.
Can you design it like that?
Yes, we'll get to that. You will have to hold on for a little longer. Huh? But for now, with the understanding that we have, just remember clone is the value, is a mechanism to get the value out. Right? You're copying, you're creating a new heap data structure. Makes sense, right? Now there is a question. I have a cache. Simple. Line number 54. I am creating a reference of string on line number 58. String is hello. I'm asking HashMap, hey, take the string. Tell me if you have a value. I get the value, I do a match. Great. What is happening? Is there a heap allocation that I'm doing in this test? If yes, where? First, creating a cache. Because cache will create HashMap. Great. That is heap allocation, which has to happen. Where is the second allocation? For the string, right? We already saw string is allocated on heap, which means I'm doing an unnecessary allocation. I'm forcing the clients, hey, give me a reference to a string. Okay, it's even worse. You create an allocation on line number 58. You use the reference on line number 59 and that's it. The allocation that you made was not justified. It was 2-line allocation, right? You didn't do anything with the allocation. You allocated. You took the reference of the allocation. Reference is like a pointer with a star mark. The lifetime of it's a safe pointer for now. And you gave away the heap allocation. Why did you allocate? What if you could avoid that allocation? Can we do that? Let's try and do that. I'll run the tests again. Okay. I'm saying give me %str. It's a new concept, right? String is an old heap allocated type where %str is a reference to a literal, really. If you say Sarthak, double quotes Sarthak, all you're doing is you're creating a reference to a string, right? Which essentially means all I can do is I have extracted the variable out of hello. Variable is called key in line number 58. You can come here. You see ID is giving me a hint. What is the hint? What is the type? %str, louder people. And now I'm able to pass %str. String is a heap allocated object. Clear? Point 1. %str, it's a pointer to a slice within a string. If slice is Sarthak, Sarthak, it is an %str. What will be the size of the variable, let's say V on stack? If I create a V, let V is equal to double quotes Sarthak, what will be the size of V? Huh? 3 words or 2 words? See, it's a read-only portion. I cannot mutate the string with an M% str, right? Why? Because it is M% str, read-only reference, which means on stack you need pointer and you just need the length. Samjha? Sarthak, Sarthak. What is the length? 7 bytes. Fair. Which means if you create a variable V of type M%str on stack, it is just the pointer and the length. Fair? Makes sense? It's a read-only view into your string. And now you do not need to do any heap allocations. Clear? Okay. We'll take 1 minute, go through all the comments, comments with question mark, smiley, or whatever that is, right? Go through all of them quickly in 1 minute, right? Let me know if you have any questions. The questions have been designed with an intention of questioning your mental model, raising further questions. If there are, we'll cover them before we move on. Done? Can you explain the question on line 38? We just did it, right? If I have to take string out of cache, can I do that with the current knowledge? How? Louder, louder, don't worry. Don't ask.
So, because you want to give up ownership, you have to delete the entry in the map.
No, I don't want to delete the ownership, right? Don't get to the state that I'm giving away the ownership. No, all I'm perfect. All I'm saying is, yeah, this is a very weird signature. I'm from Java. I don't like it. That's it. I just need an option of string. Clone it. Abhi jitta knowledge hai usme clone it. Is this cloning giving away the ownership of string? Louder. Then what is happening? How am I getting string?
Copy.
We'll not use the word copy क्योंकि Rust में copy एक अलग concept है. But you're right. We are creating a new heap allocation. HashMap doesn't care if you create thousands of new heap allocation. Agreed? If HashMap had a value E6 data or Rust conference, you clone it. Does HashMap care about it? No, because it will be a new heap allocation, which is returned to the client. Who is the client? Client is the code that would have asked for a get. And when that variable goes out of the scope, the cloned copy gets dropped. Samjha? Are the details clear? Okay. This part is clear? We were taking a reference of string in get, which means we were forcing the client to do. Correct. If I'm designing an API, right, and I'm saying, hey, I'll give you the world's fastest cache, great. I'll give you a method called get, brilliant. But you need to give me a reference of string, then the client has to do heap allocation and you start thinking about it. Anytime you're designing an API, right, always consider string in mind. Why? Mundi kyun hila rahe ho? Why? It's not primitive, sure, but that's okay. Vector is also not primitive. What is so special about, why did I make the question think about strings? String has two forms, right? In loose sense. String is a heap allocated owned type and there is an %str. We'll see the relationship between them very soon. But if you can make your API such that you don't force the user to pass string, right? Like we did. Am I creating a string anywhere on heap? No? Then where is hello going? So it cannot go on stack. It's in the binary. In almost all the languages, okay? I don't want to generalize it. When you create a binary, right, there is a portion called read-only data, .ro of the binary, where all your literals, double quotes, right, they go. Think, we are not creating a heap allocation. We are telling, hey, hello go in the binary. We're not forcing the client to do a heap allocation. Make sense? This is the first learning for designing an API in Rust. Very simple learning. When you're trying to read something, accept references. Do not take the ownership of the value. Point one. Whenever you're designing an API, pay special attention to how would this API deal with strings. And you will get the feedback the moment you start writing tests. Clear? Okay. In a previous workshop, you would have come across a concept. It would be good if the APIs are compile time safe, right? What does that mean? Does this API look okay to you? Because we are in stage 2, our cache is a hash map of string. We are not questioning that. Brilliant. But does this API look okay? Yes? Sahi lag raha hai na? Good. We are taking strings, right? We need to take strings because I want to own those strings, right? For the reasons that I do not know yet. That is okay. My key is Sarthak, value is Rust conference. What if I pass key as Rust conference, value as Sarthak? Is the compiler going to stop me? How will I know, oh, ye to locha ho gaya? Only unit tests. If you don't write unit tests, God bless you, right? Fair? Compiler is not able to help me because these are two strings that you're expecting. How do you change that? Louder. Folks from Python, how will you solve this problem? So type aliases in Python are names to the types. Who said type aliases? names to types, and they are checked at compile time, right? Okay, no, I want compile time safety. That means I am taking two strings. I should not be.
Define okay, what type of data type this function is expecting.
Both are. Array. Put is expecting string, na? Right? I want compiler to tell me, array yaar, first string is the key and second string is the value. We can create an object, right? Simple struct bana lo, key, value, cache key, cache value. What is the drawback? So what I'm trying to say is, why not have this? This type of struct is called as a tuple struct in Rust, struct without fields. That is okay, it's literature. But can I not do it this way? Cache key, you can name it anything you want. Cache value. Now, my put signature will change. It will take cache key and cache value. If I pass cache value instead of cache key, compiler will give an error. Yes, no? Bolo. See, you could use enums, sure. We are not really interested in doing type matching. Samjha? Enum is a collection of variants. For example, weekdays. If you're building a programming language, what data types are you supporting? Good candidates for enums. Yahan pe, all I need is a key and a value and uska representation. What's that?
So in Python, you're forced to basically specify that key is equal to whatever and then comma value is.
No,
You
no.
can't call a function like foo, open brackets, string 1, string 2, like this. Forced to specify the key is equal to.
No. So named arguments of methods are not supported here. This concept is called as a new type pattern. I was dealing with strings, right? I've created a new type, nothing fancy. The name was taken from Haskell. But the beauty is, there is no additional heap allocation. When you create cache key, cache value, andar ka memory layout is exactly same as that of strings. Anyone from Java? Koi tha na? If you create in Java a wrapper over string, let's say cache key, how would you instantiate it? New cache key, new string, which means two heap allocation, one for string and one for the wrapper object, which is called as cache key. In Rust, this tuple, because it is holding only one field, it will be materialized to the same layout as that of string. No additional heap allocation is happening here. Clear? Yes, no? Okay. Now, there is a little modifier over cache key. This cache key is a key of our HashMap, right? It is going to be a key of our HashMap, because HashMap pehle string tha. Now I will change it to cache key and what? Cache value, which essentially means cache key should implement what interfaces or traits? For a key to go inside HashMap, what properties should it satisfy? Don't look at this. Forget, imagine you don't know Rust. It's simple. I'm designing a hash map. I'll take any key that you give me if that key has hash. I should be able to take the hash of that key. Agreed? Yes, no? And I should be able to perform equality on the key. Simple? Simple? Okay. Partial EQ. Rust mein kya hai? Rust believes that data types, in fact everybody believes, F32, floating 32 and floating 64 are not completely equable. You can only compare them partially, right? 1.344444, 1.3339, they are partially comparable. Hence, Rust gives you partial EQ. So partial EQ, hash and EQ are interfaces in Rust. They are called as traits. And this derived thingy that you see is telling Rust, hey, implement these traits for cache key. I am not going to implement. Simple. So now cache key is hashable and also comparable, you could say that. Not comparable, but a way to perform equality on the cache key. Make sense? So my cache changes from HashMap of string to jaldi bolo. Cache key and cache value. My put is now type safe API, right? If I pass cache value instead of cache key, what will happen? Compile time error in any language, right? Almost any language. Simple? Now, what will get key take? What will get take? Cache key ki reference of cache key.
Reference of cache key.
Correct. What will it return? Option of reference of cache value. Okay, then finish this exercise quickly. Just 1 second. This is in stage 2. Huh? Now we are moving to the next stage.
What happens if I pass string to cache key?
We'll come to that. And in fact, you will realize why passing cache key looks a little verbose, not weird. Done? Nice. The difference is improving the type safety of the APIs. First, both your puts, your put was taking string. How would the compiler tell me that I'm passing a value in the key?
Because my value itself is string.
No, sir. ठीक. Fair? Okay. Now, fair? As a developer, I used your library. Great. It was a very nice library. I want to pass double quotes value in value, double quotes key in key. But because your library told me key is a string, value is a string, I swapped the two parameters. It was my mistake and I accept it. But what now? Your API did not tell me, hey, you're passing double quotes value as a key. It cannot, because both the data types are strings. You can always swap them. Let me take this out. Make sense so far? Now read it. Value is Rust workshop. Key is, okay, what am I doing? I am passing value as a key and key as a value. Rust compiler ni koi bhi compiler cannot stop me from doing that, right? Who is at fault? The developer who did that. Brilliant, I am the one. But you asked me to do it, right? You gave me enough power to do it. I did it. Samjha na? Correct. People done? It's the, I'll get there. 1 minute. It's the same solution that we did earlier. It's a form of revision also. Self.it. Nothing has changed from really the implementation, the exercise perspective. I am taking a cache key, cache value, great. But now my API is stricter. Why stricter? Let's see that. Right? Now my API is stricter and this strictness is coming at 0 extra heap allocation. Nothing has changed. Make sense? Okay. Now, I'll take one question before I touch on something else. That is what I'm coming to. Can you see something here? I have to create a cache key, cache value, agreed? Okay. But this seems verbose, right? Every time I have to create a cache key, I have to first create, let's say, a string, string colon colon from, and then tell cache key, hey, this is your string, right? ये दिख रहा है क्या? Cache key, you want to create a string first and then cache key. It's a bit of verbosity, nothing else. It's only how you look at it. It is okay you don't see it as verbose. That is absolutely okay. After you spend some time in Rust, you might start to see it. Even if you don't see it, perfectly all right. But let's assume you see it for now. Okay. Would it be nice if I could just create अरे की क्या थी यहाँ? If there were a way for me to tell cache key, I only have double quotes some string. You create yourself from cache key. Sorry. Read this signature, line number 77, nothing else. What am I doing? I'm saying cache.get double quotes hello. Okay. Let's make it a little simple. Now read 77 and 78 quickly. I'm saying hello, some function which has magically appeared, I don't know where from, but the return type. What is the data type of key? Cache key, and obviously I'm passing a louder. भूख लगी है क्या? नहीं ना? Very good. I am only passing a reference to cache key. We'll take break in maybe 7 minutes. I am passing a reference to cache key. But you see the magic on 77. Where did it come from? What is this? Pakka. What is I do not know? A reference of str, fat pointer, okay? Magically that fat pointer got changed to cache key. How? Rust gives you a trait called from that says I can construct a new type T from something else, okay? Let's do it together. IMPL, okay? From, I'll just say str for now, let's see. From is a trait. It is an interface of Java. I think Python also calls it interface. Where? It doesn't have grade. Okay. From trait tells you to implement from method. Okay. This takes a T and this value becomes a T. Okay? T is any generic type. But str is unsized. We need a reference of str. Mante ho na? We saw %str. What is %str? Fat pointer. What is the size? 2 words. Okay. I'll make it fat pointer. Let's make it fat pointer. Done? What I want to do? Cache value again. Okay. I'll create cache value. What does cache value need? It needs to own the string. Agreed? Okay. You gave me %str and there is a way to construct that to a string. Yahan pe there is a heap allocation happening here. We any which ways can't get rid of that. Your question, sir. What if I pass a string to whatever? If you remove this, it is %str, get is failing. So we'll put fail, right? But if you just have string, just add into. Into will call from. From of what? From of this. Construct a type which is deduced by this. Samjha? Into will call from. On what? जिस पे into call किया गया, the thing on which into was called. It will construct something, correct? What should that something be? That should be what is get expecting in this exam. One for cache key, one for cache value. You tell me, how would it, so his question is, there is a from on cache value, there is a from on cache key. Both of them are on % of string, right? Agreed? Okay, nice, very nice. When you call into, how does the Rust compiler know which from to call? How would it know? Ah. Correct. Line number 79 is a hint to the compiler that 79 get, what is the signature? What is the signature of get up? वहाँ दिखेगा ना? What does it take? Reference of cache key, correct? Which means line number 78 का outcome क्या होना चाहिए? Reference of cache key, simple, okay. Which means if I were the compiler, or rather I was building one, then I have enough information by peeking ahead. Hey, I need a cache key. Can I get cache key from double quotes hello.into? For that to happen, double quotes hello should have a from implementation that returns me a cache key. Okay, let's verify that. Cache key. Make sense? Yes, no? Are we good so far? Any reads are taking references only. We are not taking ownership, right? Any data structure, HashMap vector will own its values. To give out the values, so far we only know clone. Where? What is a new type pattern? A way to construct, a way to create wrappers over existing objects like strings, integer, whatever. Does new type come with heap allocation? No. The memory layout will be same as what your new type is wrapping. Simple. Just with introduction of cache key, cache value, our cache ka put API is type safe in a way, right? Type safe is the right word. I cannot pass cache value in cache key. मानते हो ना? पहले ऐसा नहीं था. Clear? Good so far? Okay.
So this typecasting, right? We can create our own type of class, and in Python we can implement this kind of very like a check for inserting the key, for inserting the value. So what is the trade-off?
So his point is, I'll take this as the last question. His point is, if you could create types and do a runtime check on some types, right? We'll not go into details of those checks for now. If you could put a check here, agree? कैसे करोगे check?
What I'm saying, the type check, right? कैसे key, कैसे value you created in Rush, right? And then you are putting before key, before कैसे value, right? Okay, this should be key, this should be value, right? You are putting in a Rush, right?
See,
key or key cannot become the value, right?
Correct.
You are making this check, right?
I am not making, compiler is making.
Compiler is making this.
At zero cost, huh? There is no runtime cost.
That is what I want to understand. How zero cost?
Why? See. What is cache key? Read it out for me. Louder, louder. वो hash जान दो, that is all right. What is cache key?
Cache key is kind of struct type.
It is a struct. In Rust literature, it is called tuple struct because it does not have named fields. Okay. How do I create cache key? By passing it a string. Now Rust has two options. It will any which ways do heap allocation for string, right? Does it need to do heap allocation for cache key? Rust designers said, if your new type encompasses just one field, right? You do not need to do extra heap allocation for the cache key. So compile time के बाद, all you have is the layout for cache key. Heap memory layout is the same as that of string. No additional object gets created for cache key. That's it.
So where it will get it?
Cache key is not stored anywhere. You can imagine cache key is gone. One way to visualize, just restricting it for now, cache key is just a wrapper over string. ठीक? Compiler क्या करेगा? Compiler will compile, great. When it comes to allocating heap allocation will happen at runtime, right? It cannot happen at compile time. Okay. runtime, I mean, when the program is running, you need to do heap allocations. Heap allocation jo hoga, that is for string. Great. Now, cache key ka literal existence is not really there at runtime. It is only for the compile type safety. Just visualize it for now, right? We'll improve it as we go on. So new types ka there is the new type that we have created does not have any runtime performance. No checks by us. Compiler ko jo check karna hai karta rahe. That is all right. Is there a runtime cost? No, there is no runtime cost. Make sense? ठीक है, अभी wait करो. हाँ, you have 1 minute. Go through the comments of this exercise. Well, lunch break कितनी देर का लेना है?
At least half an hour to go.
At least नहीं, half ही रखते हैं ना उधर.
ठीक है. So we can say 2 to 5
5 minutes and we'll break. It's on the way. Should be here anytime. 5 minutes.
5 minutes, ठीक है. Read these comments. These were prepared for people who are attending this. With a hope they'll help. सारे पढ़ लिए क्या? हाँ.
So we have that log into, you can directly call it inside the function itself. Like dot put and it value dot into first and so then it would you would sort of lose this type here.
Correct. Because what you're expecting is a string only. Into किस पे करेगा? You have to do it on, let's say, double quotes.
Into is causing the issue.
Correct. Remember, this is not really typecasting, right? Typecasting means you're saying, hey, I have an integer, please cast it to long, promote it, demote it, whatever. I have a string, I don't want you to typecast it. No magical thingy, right? Let's say in Java, you can correct me if I'm wrong, int could be typecasted to long. If that is the theory, then that's magic. I don't know as a developer. I don't want to increase the size of long. I would like to be explicit. That's my preference. Okay. Here, double quotes hello is not typecasted. I'm saying here I'm calling a method. You call that method, construct cache key, cache value, whatever, and then operate on them. There's no casting really. Sorry, what was that?
I don't see any into implementation. Is compiler?
Yes.
In that case, can I implement into uncompiler?
No. I'll go there. So, into is another trait, right? Read the implementation of into. Jaldi. I'll increase the size.
I say it requires that time must implement from.
Perfect. You can call into on any type u, where u implements from. This is a signature we'll come to in the next class. You should implement from. If u has a from, now you're done. You can always call from on u passing self. समझा ना? We were calling double quotes hello dot into. It's not magic. This is the double quotes hello. Agreed? Call double quotes hello ka from method, right? Passing the self, correct? Make sense? ठीक है. Any other question?
Basically, this new type is not overhead, but I see that it's a kind of a CPU boost.
Yes, perfect. So he is very right. I'll be honest, I was willing to call it out. There is no runtime overhead in terms of memory, right? We're not doing any heap allocation. But ये from call करना, into call करना, right? These are taking CPU cycles, right? There is no memory that is going on, but CPU cycles will be spent in order to construct these objects. But what's your name? Papun, do you see this? Right? It is very early for us to see this. Inline, we are telling Rust compiler, wherever this function is called, do not call this function. Bring the code of this function into the call site. Almost all languages give inline, direct or indirect ways. For example, in Golang, anyone from Golang? Nice. Golang gives inline? It does. Any function where the cost of the function is less than 80 units and the size of the function is not bigger than, it does not involve some n complexity, the function becomes inlineable function. Inlineable function is a function which will be brought to the call site. Function call ka overhead, there is no function dispatch. You know how functions are called, right? Kaise? What do you save on stack? If a function call is called from line 178, after the function call is done, I need to come back to line 178. I need to put instruction pointer somewhere. Okay. Function takes n number of arguments. I need to move those n number of arguments into some registers and then call the function. Function call gaya. It will read those arguments from the registers, do its job, and then return. Return back to where the instruction pointer was, where I had stored in a register, right? None of this happens. Why? Because the function is inlined. Make sense? So yes, there is a cost. It is very, very minimal. You can measure it.
So if the cache value or cache key does not exist at runtime, where do you need this from money?
We will get to that. People, it's 1:40. Let's take a lunch break. Let's be back by 2:15. Okay, I'll start at 2:15. Okay. 45 minutes good for you? Not make it good for you. Thank you, people. Okay, people, back. So, in the first stage, we made our cache, which was a hash map of string. Fair? Simple cache, yes. It had put. What was put taking? Quickly. Put was taking strings, right? Cache needs to own strings, okay? Put also needed a mutable reference to cache, right? Why you need a mutable reference? To be able to mutate anything, right? Yes, no? Okay. It also had a get. Get was taking a reference of string. Then we realized, array, if get takes a reference of string, every time somebody calls a get, they need to perform a string allocation, right? Heap allocation. And then waste it. What did we change it to? Louder, people. $str and str. What is that? Reference to a string slice. It is a peek, a view into a string. A fat pointer. Size is known at compile time. What is the size of $str? 2 words. On a 64-bit machine, 2 words is 16 bytes. Theek? Then we realized our put signature takes 2 strings. We need compile time safety. If somebody passes value into key, what did we do? New type pattern, right? What were the new types? What was cache key implementing inside the derive, if you remember? Partial EQ, hash and EQ. Hash because cache key needs to be hashable. Partial EQ because Rust says not every type is completely equable, right? Hence partial EQ, and EQ is a marker trait. Okay. When we implemented this, we realized their cache key or cache value ka construction is too much, verbose. What did we do? We said it would be good if we could just take hello dot something, right? That dot could be an int2, which will construct cache key or cache value itself. Good so far? Quick revision? Okay. Can we make our cache generic? Generic meaning a data structure which can take any type T. It will work on any type. And compiler will take care of ensuring that types are, respected. You have generics in Java, C++, right? Golang. This is how generics look in Rust. Can you read it out for me quickly? What does that mean? Type is K. It seems like a key. Fair. There is a V, which might be a value. You can't infer that. Okay. When you read the next line, you say, Array, K means key of the hash map. V means value. Yes? Okay. Will any key work with hash map? Perfect. Whoever said hashable. Anything else? Partial EQ, sir. Anything else? EQ. Okay. Let's make it. Both the signatures are same. They are doing the same thing. I want to have a cache which works on any K, any V, but K has to be hash and EQ. Right? Make sense? Okay. You can choose any signature, but in general, when you start working with Rust, you will automatically come to where signature. If the number of constraints on your type increase, this line increases so much. So you can switch to where. No difference in general. Okay? Simple syntax? Okay. Let's solve this together. Okay. I have a cache, KV, clear? This is stage 3 cache.rs. Now, can someone read this for me? The IMPL thingy. See, our struct cache is saying I am generic on KV. K is hash and EQ. IMPL of KV. Here, you're declaring KV. This is the declaration of the parameters. Okay? Okay. Now, can you see it on line 18? Right? Declaration of KV. And your cache is obviously generic on KV. And then your where. Clear? Yes, no? Okay. Does anything change in put? Nothing changes, right? You're just taking any key, any value, till the time key is hash and EQ. Okay? Okay. Does anything change in get? Are you sure nothing changes in get? Go back to the first get that we implemented. What were we taking? Reference of? Okay. What will we take now? Reference of? Arey जोर से बोलो. K. What did I tell you in the first class? Whenever you're building an API, if you're building a read-like API, you will take a reference. Brilliant. We are taking a reference. Point 1 done. Are we taking a reference of K? Obviously. Why? Because our hash map is KV. Correct? Let's look at our hash map just to confirm this. Yes. Hash map is KV. Clear? What was the second point I told you when you're designing your get read type of APIs? Think about string. What if someone designs a cache which is a string, what will this get signature force them to pass? Reference of string, correct? But they will have to do a heap allocation of string. Agreed? Mante ho na? Okay. Can we improve this? How did we improve in the first class? I mean, first stage. Reference of str clear? This side clear? Okay. How do we do that? Now we don't have string str. Now we have kv. Okay. What if you can have a method called getImproved? Leave the method name. What if it works on any queue? Can it work on any queue? Now tell me, can it work on any queue? What does this queue need? I am saying to build a method, getImproved, which will work on any key which is a queue. Queue is a type, right? First thing, start with the basics, jaldi. Where queue needs to implement hash and eq. Okay, good so far? Okay. Let's assume somebody designs this cache for string. Simple. Cache is generic over string. What we want them is, they should be able to pass %str in getImproved. Yes, no, people? Yes? Okay. Which means there has to be a relationship between the k which went into HashMap and the q. Yes or no? एक बार सोच लो. We designed HashMap for string key. Okay. Now we are saying, I want get to work on %str. There has to be a relationship between string and %str, right? Which none of you asked in the first session. If HashMap is on string, why is %str working as a key? कोई तो relation होना चाहिए ना? Otherwise, I can pass an integer, फिर भी lookup चलेगा क्या? नहीं, right? Okay. Which means I need to establish relationship between k and q. Agreed? Rust में there is a trait. Trait is interface, which is called borrow. What we are saying is k should implement borrow of q. What is q? Type, but in the conversation that we are having, %str. If k gives me an %str, I'm good, right? If k allows me to borrow a reference to q, I'll be good, agreed? क्योंकि फिर तो बात same हो गई ना? You gave me an %str as a lookup key. HashMap was on string, which means the writer of the HashMap could clearly say, hey, k implements borrow of q. K can give me a reference of q. Correct? Yes, no? Okay. If this is the case, let's see if everything works. Okay, there is a problem. getImproved, I am passing what is getImproved taking? Reference of q, okay. Q implements hash and equal. Good so far? I have to establish a relationship between k and q. K should give me a reference of q, which is borrow of q. But still compiler is telling me rustconf does not have a size known at compile time. Why? I am passing a double quote string, right? Which essentially means compiler saying, I don't know its size, right? What if you give me a queue that is fine. What if you give me a queue? I have established the relationship between K and Q. Simple? Okay. I've also said Q should be hash and EQ. Okay. Now compiler is telling me, hey, Q can be optionally sized. Why did it say this? Rust में कैसा होता है ना, all your generic parameters, any parameter, this is sized. इसका मतलब size of K, size of V, by default size of Q is known at compile time. ठीक है? Now, when you're using Q without this, does compiler know that you're going to pass an ampersand string? I mean a double quote string, right? It doesn't know that, which means compiler is saying the size of Q I know at compile time, right? But when you're passing a double quotes Rust con, the compiler does not know the size of this double quotes Rust con. Hence, it is forcing us to have sized. Make sense? That's right. You give me any queue that implements hash plus EQ, and I don't care about the size at compile time. It is okay even if you pass me a concept, right, which satisfies these constraints and the size is not known at compile time. It doesn't matter to us. Remember, see, what did we want? Our cache is working on K and V. K and V can be anything, agreed? V can be anything, K needs to have hash and EQ, okay. Rust also forces K and V to have a size known at compile time. That's the default constraint. Without you saying question mark sized, their size has to be known at compile time, okay. I want this method to work directly with this string, right? I don't want to say this, right? A reference of this. ऐसा नहीं करने का. For Rust, what is X? Ampersand str, okay. Let me remove this. Why is compiler telling you, array, I don't know the size of Q? It's not the problem that Rust conf is an ampersand of str, right? Rust needs a generic type जिसका size can be known at compile time for this parameter to be satisfied. See, are we implementing our own get or HashMap's get? No, we are not implementing our own. We are actually delegating it to whom? Are we implementing our own HashMap? No, we are just delegating to the underlying HashMap, okay? Which essentially means I can work with this signature, right? Q ka constraint and K or Q mein relationship, agreed? But if you look at the signature of get inside the HashMap, K implements borrow of Q, expected, yes. Q is hash and EQ. Are we giving it? Yes. At the same time, Rust is telling us, hey, give me a Q whose size I don't know. I don't care about the size. Okay? Which means now the callee of this get, we are the callee, right? Callee of this get needs to say, make sense? Yes, no? Yes, no, people? If the library is telling you that the constraint on a generic parameter is A, B, and C, when you're calling that library's method, your generic type Q has to satisfy all the constraints. Agree? Make sense? Okay. So now our cache is generic. Your cache works on any KV such that K implements hash and EQ. Simple? Okay.
Sarthak, question online.
Put is straightforward. Yeah. Put is straightforward. Clear? Get is taking a reference of K. Anytime you see a reference of K, you have to think about strings. That means this method will cause heap allocation for strings. Agreed? Correct, na? And that is why we want to improve get. Yes.
So then this kind of scenarios where we need to explain this, like let's simply say, okay, this time should be should not be known at the compile time, or we are not telling you. Why not compiler itself is making the question mark size?
See, majority of the cases that we deal with, we'll be dealing with types where the size is known at compile times, right? For example, when you create a string, you don't know the size of string, but you know the size of the variable on stack, don't you? What is the size? 3 words, 24 bytes. What will be the size of a vector V? We don't care about the heap allocation, we know V, right? Which essentially means by default, my priority as a Rust builder, someone who created Rust, I want to deal with types where the size is known at compile time. I don't want to have types wherein I don't deal with sizes, right? Because if that were the generic parameters, agar parameters aise hote, sizes were not known at compile time, if this was the majority, what would the underlying language give you as a guarantee? In terms of, if the size is not known at compile time, how are you going to handle the allocation of those types? If you invert this decision, most of the parameters have a guarantee that sizes are known at compile time, right? You take care of all these issues because size is known at compile time, heap allocation is happening, that's all right. But I know what is going to go on stack in terms of size. However, you still need types wherein you will use question mark. We'll come across concepts jahan pe you will see the underlying type tells you, hey, don't implement sized. Wherein, we'll come across concepts, hold on for a little while, wherein we will tell the compiler, I can deal with unknown size types. Okay? But that is the time you will realize, hey, why it makes sense to not have that as the default in the language. Ankur, too much to type, that's okay. I mean, I don't have a comment on that. I think the size of string literal is known at compile time, that's right. The problem with get improved is it did not specify, no. So Ankur, the thing is, You're right. The size of string rustconf, if you take rustconf out, you can see. You don't need to know the size of rustconf per se. You need to know the size of x, right? X is a variable holding rustconf. We have already seen in the previous sessions that the type of rustconf is an %str, right? It's a reference to an underlying slice, which means iska size is 2 words. On a 64-bit machine, it is 16 bytes. But the second part that you said, I'll slightly correct it. In entries, we are delegating our get to HashMap. If you go into get of HashMap, which is again an inlineable function, that's all right. What we are saying is, hey, you give me any queue such that k implements borrow of q, q implements hash and eq. And you can optionally give me an unknown sized queue. Hence, for this get to work for us, we need to force queue to be optionally sized. Make sense? Make sense, people? Because we are delegating to HashMap's get. अगर HashMap का get बोल रहा है, I can only work with queue such that queue is optionally sized. Queue can be optionally sized type, right? Which essentially means your get improved should also accept any queue which is optionally sized, right? Ankur, hold on to this question, why is size mandatory for us? We'll get there soon. Even HashMap specified queue to be opt. No, you're mixing the concepts. Only queue is optionally sized. If you look at the source of HashMap, HashMap never says KV are optionally sized. Majority of these types, KV, they are sized. They are fixed in size. They are fixed in size. But Q in get, HashMap says, hey, I can deal with Q even if it is optionally sized. And we'll get there. Why it makes sense to have generic types as sized by default. So remember, this is only for get. HashMap is never saying, hey, I can work with optionally sized types. No. HashMap is saying, give me any KVS, whatever, such that they satisfy this constraint along with the default constraint that my generic types are sized in nature. Okay, if few people have a question, why is generic type sized by default? Hold on to that question for a little while. But for now, is this part clear? Fair? Okay. Is the borrow part clear? We had to establish the relationship between K and Q, right? Otherwise, your hash map is on string and what you're passing for a lookup is an %str. That is clear, right? We want to have a relationship between K and Q. Q is what I'm giving you. Clear? Okay. You have to, yes. So if your hash map is working on type A and type B, right? Correct. Cache key was my type for key, cache value is, we are not bothered about the value. And you want to pass any queue for a lookup, then your K implements borrow of Q, correct? Which means your cache key should give you that borrow, reference of Q, only then your get will work. So you will be forced, compile time safety, you will be forced to implement that borrow. Okay. Now, this is very important, okay? We have been talking about references. I've told you references are pointers in Rust, okay? Uh, pointers with life managed by Rust. Now, that is the part we have not covered yet. What does it mean to say, hey, I'm giving you a reference, take it with you? I'm giving you the ownership, sure. That means the ownership has moved away, fair? But what does it mean when someone says, hey, give me a reference or take a reference, right? We are yet to attach lifetime with a reference. Before that, Ankur has a question, new question. We need to work with queue passed in the HashMap. Is it right to say just because queue is hashable? No, it's not. So Ankur, our HashMap is working on KV, okay? K can be hash and EQ, very nice. Our get is taking any queue, which is also hash EQ, ignore sized for now. K takes borrow of Q. This is the guy that is establishing the relationship between K and Q. Which means if you go through the source code of HashMap, what HashMap will do is, it has a key, right? Key is a string, for example. Q is a reference of str, ampersand str. It needs to make both the types work. But it knows I can only give you a Q such that K allows you to borrow that Q, right? Which means internally when HashMap does a lookup, right, it will perform K dot borrow. Only then the types will match. Okay? Okay. Ankur, sorry, if I have time, which I highly doubt, but I'll try and, can someone remind me to take 5 minutes, because this question is very nice from Ankur. I want you to go through the source code of HashMap with me. We'll do it in 5 minutes, but someone remind me. If you don't remind me, it's your loss. Ankur, ek bar we'll also check the source code so that this point becomes very clear. Now, I want you to implement get mute. See, it is the same thing that we've been doing, right? Put implements, self.entries.insert, get implements, self.entries.get. How will I implement a mutable reference? Okay, before that, can someone explain me what we are doing here? Jaldi. Perfect. We are getting an optional, nothing new. We have added a new keyword. I mean, you have already seen it. Mutable reference to V. What will it allow the clients to do? Perfect. You have a mutable reference, you can change it. Okay. Self.entries.getMute. Simple. We are delegating to HashMap. We are not implementing our HashMap. Okay. Do the tests pass? Sure, 1, 2 fails, which is fine. But I want you to learn something which is very important. Tell me what is happening here in these two lines, whatever. Get mutable values. Read lines 117 to 121. We are getting a mutable reference. It gives us an option. Now, in test, we do an unwrap to get the value out of option. Okay, fair. This is a mutable reference to string, agreed? Can you see it? Okay. I have a mutable reference. I want to change it. How will I change it? Dereference the value. C++ folks, Golang folks, dereferencing a pointer, that means get the value. Change it to a new heap allocated value. Agreed? Make sense? Okay. Same thing here, nothing new. And when you do a lookup, you get the updated value. Clear? Okay. Now, I want you folks to answer this. Again, I am putting two values in cache. One is called as rustconf, other is dbconf. 2026, I get the mutable value to rustconf. I get the mutable value to dbconf. And I just want to assert their values. Nothing fancy, right? Is the code visible? Okay, let me run it. Read this, tell me what is happening. No, first read it. Go slow. When we are calling the get mute, we are passing mutable reference of cache in this. Why? Because this is what it asks. Okay. Then what? Okay. First thing, you agree we are passing a mutable reference to a cache and get mute? Yes or no? Okay. What are we getting back? Jaldi, what are we getting back? Mutable reference to a of the value, which in this case is a string. Brilliant. Now, again we are calling a get mute. We are getting a mutable reference to a value. Rust will not allow you to have two mutable references to one type in the same block. What does that mean? Will this work? काय को मतलब एक प्रिंट एलन ऊपर करने से सॉल्व हो जाएगा? Somehow it worked, okay. But the moment I do a command X, whatever, command V, it says it doesn't work. So the solution is moving asserting Q up. Is that what we are saying? Perfect. See, when you say I am returning a mutable reference to a string, great. So, iska data type is %mute string, right? And same is the case with this. I am not going to write again. Rust does not allow more than one mutable reference to a type T. Okay. What is the lifetime of this reference? How long is this reference living? This reference is alive till the end of this line. So, I live till the end of this line. Who am I? I am rustconf_value. Visible? Rustconf lives till the end of this line, last assert. Agreed? Okay. But is rustconf an independent value or a referenced value? Where are we referencing it from? Cache. इसका मतलब can the cache be deallocated before rustconf? Why? We took the reference from cache, which means to avoid dangling pointers. Cache must be alive till the time any borrowed references are alive. Agreed? Okay. Which means cache, uska mutable reference is alive. Ignore the typos. REFEREM. Agreed? Because you are getting a mutable reference which is alive till the end of last assert, your mutable reference to cache is also alive. Agreed? Which means when you are getting another mutable reference, Rust will say, hey, there is already one mutable reference to the cache, not to the value, to the cache. Samjha last part? Because you are borrowing a value, you are borrowing a value from the reference. That means you are borrowing a value from the reference of the cache. Cache cannot go away. If cache goes away, let's say if hypothetically, if this cache were garbage collected, there is no garbage collection. I have a reference to a value from the cache which was just garbage collected. The value is a dangling value, right? Agreed? Value is alive, which means cache ka mutable reference is also alive. Correct na? If one mutable reference of cache is alive from here to here, I cannot have another mutable reference within the same block. Make sense? Huh? You have mutable reference. We have not returned value. You have to change your line.
No, the mutable reference to the value.
How will you get a mutable reference without keeping the mutable reference of the cache alive?
Sort of don't need that.
You need that. If you do not, then you're missing on the type safety. See, I have the mutable reference of the cache. I will somehow give you the mutable reference of the value. Brilliant. Value can live however long it wants. Who owns that value? First, who owns that value?
The cache.
Which essentially means cache ka reference has to be alive. Now, two questions. Is it okay if I downgrade the reference of the cache to, let's say, shared?
Yeah.
No. If the reference is not alive, what if hypothetically, by following your statement, by this line, if you're saying cache ka mutable reference gets downgraded somehow, okay? देख, अगर कैश का म्यूटेबल रेफरेंस शेयर्ड बन गया, all you have given rise to a lot of data race conditions. Imagine कर एक vector है, you have a vector, you get an iterator. How you get? Using a mutable reference, let's say. Now, while you're iterating, what you do not want is someone else changing the values in the vector, right? But because you said I'll downgrade it, okay, now you downgraded that mutable reference to a shared reference. Someone else, while you were actually holding a mutable reference, can change the entire vector.
What if we downgrade both of these to like?
ऐसा नहीं होता. You have a mutable reference to a type T, which is inside another container, cache. Cache will have to live as long as the reference lives. Point one. Cache cannot die before the reference, else you're dead. Right? If the reference was a mutable reference of the cache lives. It is in your hands to reduce the scope. Which means when you were moving it here, what were you doing? Get me the mutable reference of the cache. Okay. Get me the mutable reference of the cache. Return the mutable reference of the value. But the mutable reference of the cache goes away immediately after this line. Now you can do another mutations. This is serialized mutations, simple. When we get to threading, the point that you raised, what if I downgrade it? That would actually allow threads, multiple threads, to have mutable references to the same cache without needing the locks. Wo we will touch when we get there. Yaad dilana. Is this part clear? You can have only one mutable reference to a type T in a given scope.
What if I have one mutable reference and a read-only?
Good point. You cannot. Mutable references are exclusive. Shared references are not. What that means is, I can do that. Infinite number of read-only references are allowed. Fair? Read-write lock में क्या होता है? Any number of read locks are allowed. I have a mutable reference here. Look at the code. Tell me what is happening. Line number 148, you get a mutable reference. You get a value, great. It's a mutable reference to a string. What is the life of this reference? Till line number 193. What is the life of the mutable reference of the cache? 193? Sorry, 153. Sorry, 150. Now I say, I want to get a read-only reference. Sure, get the read-only reference. What is the life of this reference? Till line number 152. But there exists a mutable reference spanning line 148 to 153. This is data race if this were allowed. एक बात बता, जब ये read करेगा, which value will you get? Let's say if there were a mutation here and here, which value would you like to get? Right? So one is allow data races, have two mutable references, जो होना है होता रहेगा. Second is, if the mutable reference of the cache is alive here, do not allow any read-only references. Mutable and read-only references are, they cannot coexist within the same scope. Write-only references or mutable references are exclusive. Doesn't matter. This foundation is the foundation of multi-threaded. I'll touch this. Multi-threaded में भी same concept चलेगा. तू सोच, you work in Java, right? Oh, which line? Python में mutexes होते हैं क्या? Read write mutex होता है? हाँ? Are write locks exclusive? Obviously they are. That essentially means when you say read-write locks, your writes are exclusive. When one thread is holding the write lock, no other thread can hold the read locks. What if you shift this foundation to even single-threaded apps? Imagine an iterator of a vector. You have an iterator, you're iterating. Would you want someone else to mutate this vector while you're iterating? Which means if you have a mutable reference to a cache, you know, even in a single threaded application, there is only one thread mutating it. Fair. What if this concept was not allowed? Now you have multiple mutable references to cache, multiple mutable references to the values inside it. If you have allowed multiple mutable references, you have also allowed multiple shared references, right? When I'm reading, what am I supposed to get? You can say, hey, I can return you the last write wins, which is not the answer, because you have maybe lost a value which was updated in the middle way. Samjha kya? Better is don't allow it. Doesn't matter. For compiler, these references have a lifetime. We'll get on the lifetime थोड़ी सी देर में. Lifetime मतलब what is the duration for which a reference is alive? The mutable cache, right? The reference of the mutable cache is alive till this line. Imagine it in terms of lines. Which means cache is borrowed mutably, which is an exclusive reference. No one can perform writes or read while this reference is active. Mutable reference is active, right?
So if somehow we want to use it at that line, we have to get our own version of it, right? To free the table.
Correct. देख mutable reference में कैसा होता है? Again, same point. One option is you change the API. Do not return mutable reference. Provide a signature which is update, and update does the job for you. Okay. Second option is if you really want a mutable reference, the caller will have to limit the scope of the reference. Correct, na? So compiler is protecting you from doing data overrides, creating data races. ठीक है? Make sense? I'll leave update for now. Sorry. अबे हाँ करेंगे. अभी नहीं मतलब towards the end. क्योंकि पूरा टाइम है HashMap करना है. Tell me one thing, the cache that we have designed is on KV, agreed? HashMap है. Is it thread safe? Okay. How many yeses, how many no's? This is stage 6. Is this cache thread safe? How many yeses? Ankur says HashMap is not thread safe. Nice. How many of you say this cache is not thread safe? Okay. 1, 2, 3, 4. So that means 5, 6. Everyone else says it is thread safe. Okay. Okay. I created a thread, okay, and I said, so I created a thread. I said, hey, I want to put a key and a value, and it seemed to work, but HashMap does not seem to be thread safe. It doesn't look as if there is any lock in the HashMap. How did it work? People on chat, if HashMap is not thread safe, how did this code work? Sorry? Correct. What we said was, hey, I have a cache, okay? I am giving the ownership of this. HashMap is not thread safe due to mutable ref. That's right. See, what we have done is, we created a thread, okay? We told that thread, take the ownership of this HashMap, I mean this cache, and do whatever you want to do. This is a single threaded concept, okay? Let's try one more, one more thread. Now, can you see the error? We have seen this error in the first stage, wherein I was talking about vector. When you pass a vector to a method, you're actually passing the ownership completely, correct? Which essentially means at compile time, it's an error. I'm saying to this thread, hey, take the ownership of this cache. Why? Because cache should be alive till the time thread is alive. Agreed? Yes, no? Okay. Which essentially means thread could be alive for a year. I would like that object cache to be alive for a year. Else thread is working on cache which has been kind of dropped, right? Agreed? जो भी objects thread के अंदर हैं, उनका life has to be at least as much as that of a thread. Okay? So मैंने thread को बोला take the ownership. If I do not do it, cache is borrowed here, ठीक है? Thread का जो lifetime होता है, that is static lifetime. That means it will live forever. Okay? Which essentially means cache has to live at least as long as the thread. Okay? So I'm saying, okay, if you're saying I'll move this cache to you.
So you are defining cache, right, 07, and that goes out of scope only in line 116. So that's well within the scope.
No, you're assuming well within the scope, okay? I have a thread which is running on core 1. I have another thread running on core 2. This thread takes this thread is going to run forever on core 1, right? This thread may finish quickly, that's all right. How long should be the lifetime of this object cache? How long should it live? Huh. This will wait till the time this thread is done, correct? Which essentially means cache should be at least alive as long as the threads are running. Samjha na? And threads have a lifetime of static, which is a special lifetime, which just imagine that your reference is going to live forever. That means thread is going to live forever. I need to guarantee cache lives forever. I cannot. Cache will drop after this function. Yes? If cache drops after this function, what is this thread working on? So another compile time safety. Thread needs to work only on the objects which are well within the scope and alive while it is doing the work. Okay, I can do this. Right? So threads running on some processor will have some lifetime. That lifetime will be forever. You don't know when will they end. For example, classic background workers. You don't know when they'll end, which means they need to take the ownership. How you give them the ownership? By saying, hey, you take the cache with you. If you're taking the cache and you're trying to move it twice, your compiler is straight away rejecting. Right? The previous example worked because of this, right? It is a threaded app, single threaded concept. We moved the ownership of cache inside the thread, correct? Yes, no? Okay. So is our cache thread safe? Right? We need to make it thread safe. What is the simplest way? Mutex. Can you read this? Jaldi, can you read this? Correct. Read-write lock of HashMap. We already had a HashMap. We are not changing it. We are just saying, hey, read-write lock, take the ownership of the HashMap. Right? Now, read-write lock is owning the data. Make sense? Yes, no? Okay. So we are saying, hey, read-write lock, take the ownership of the hash map. Okay. How will put be implemented here? Take a write lock and perform an insert. Okay. Let's try and do that. Yes? Simple? Okay. Now read it for me, jaldi. Self.entries.write, get the write lock, okay? This write lock returns me a result. जैसे हम लोगों ने option देखा, वैसे ही Rust में result होता है. Result is an enum which has two variants, okay and error. It could either be successful or it could fail. Now, the question, why would acquiring a lock fail? Maybe? Which is fine, then this thread will be blocked. So let's say you were thread 1, you had already acquired the lock, you were doing this line. You're very slow, let's just say. I am another thread, I am trying to acquire the lock, right? When I try to acquire the lock, if you're already holding the lock, I'll be blocked, which means CPU will take me away, put it into a blocked queue, that's it. But why would a thread trying to acquire a lock fail? So in Rust, there is a concept called poison lock. There is a thread 1 which has acquired a lock. Let's say he is the thread. He was doing the job, but he panics. Very much similar to your runtime exceptions of Java, right? You panic. The lock is marked as poisoned. Any other thread trying to acquire the lock will fail. Why? Perfect. The thread, he was the thread. He could have corrupted the data. He could have done partial writes before he panicked. Samjha? Another safety. This safety will happen at runtime, of course, but safety nonetheless. So first, we acquire the write lock. So now I'll combine these lines. Self.entries.write. Write lock dot unwrap. Write tak I get a result. I do an unwrap. Okay. Unwrap will, agar error hai, to it will panic and return. I get a guard. We'll see what that guard is. Can you see the type? What is the data type? Read, write, lock, write guard. It seems like a guard of some sort, and somehow the guard is allowing me to do an insert. Okay, fair. We'll get to this in a bit. Guard, ये insert किसका method था? Which method? HashMap. Somehow it has magically appeared on the guard. Okay, let's see if it works with get also. Okay, right? This time I get a different guard. Read, write, lock, read guard. Okay. What are the few things that you observe? Have you ever used locks in your languages? Yes. How do you free the locks? It's not about defer, non-defer. Do you explicitly free the locks or lock is handled by someone else? Explicitly. How do you do it in C++? What is RAII? What does that mean? Somehow, people, we don't have to drop the lock. We acquired the lock, right? Self.entries.write.unwrap. Unwrap because we are getting a result. Fair. We get a guard. Point 1, guard magically has an insert, we don't know how. Point 2, we don't drop the lock. Mante ho? These 2 points, everything else is simple? Okay. Let's look at get. Let's look at read, write, lock, read guard. Can someone read it out for me? Read, write, lock, read guard is a struct. I'll leave the take K for now. It works on any T, even if that T is optionally sized. Why? Because internally it is a non-null. What is non-null? It is a pointer. कोई फर्क नहीं पड़ता उसको. Clear? Hence optionally sized. Tick A. Okay. When we created a cache, we had HashMap. Cache was owning the HashMap. Okay. Read, write, lock, read guard is holding a reference to something called as system.lock. Can you read this line 115? Correct. This object, read guard, is holding a reference to read, write, lock. Correct? What is the implication of this? It doesn't own. Perfect. What else? Can this guy outlive this? Why? What? You will be losing the lock, okay? Lifetime is associated. See, read write lock read guard cannot live longer than the reference denoted by a lifetime tick A. Tick A is used to denote the lifetime and tick is used to denote the lifetime. A can be anything. If this guy lives longer than the reference, that means reference has gone. This guy will be pointing to a dangling or a garbage reference, right? Which means this guy can never live longer than the inner lock. Make sense? Okay. It is holding a reference. This is how you declare struct holding a reference. Okay? We have been talking about drop for a long time. What is drop? Drop is a trait in Rust. Anytime a value goes out of scope, उस value का drop gets invoked. You implement drop for read write log read guard. What is it doing? It is releasing the lock. Leave the unsafe blocks for now. Make sense? Which means the moment this line gets executed, or rather this line, guard has gone out of scope. Yes? Guard has gone out of scope on line 36. Yes or no? Drop of guard will be called, which will release the lock held inside the guard. Clear? Okay. Let's run the tests once. I think I would like to return a reference of V, right? We have been returning a reference of V, correct? Let's return the same. Now tell me what happened. I will also show the code. I obtained a guard, which is a read lock. Guard is wrapping my read lock. Guard.get. Get is a get of HashMap, right? We'll see how did get come here. But the compiler is saying something weird. Returns a value referencing the data owned by the current function. Guard is borrowed here. What does that mean? Guard should live as long as the reference. Who owns the reference now? Go back to the signature. Who owns this hash map? Jaldi. Read write lock owns the hash map. Pehle cache was owning the hash map. Which means if I'm returning a reference, what does that mean? The lock should live as long as the reference. Okay. But lock is getting dropped here. Correct? I can't make the lock live longer. I can't return the lock guard for now. Okay. So, guard is getting dropped, which is dropping the lock. Na, अपन ने देखा ना. ये guard है, right? This is your guard. If you look at the drop of this guard, what we are doing is, दिख रहा है क्या ये read unlock? We are not going into read unlock. Read write lock का existence, the object is there, right? Why? Because it is there inside your cache, but the scope of the guard is gone. As soon as guard is gone, the thread that was holding the lock has released the lock. Samjha? Now what is it that we can do? In the first exercise, what did we do to return the value? Clone. With the knowledge that we have, can we do clone? I get the read lock, I get the guard. Brilliant. Guard goes away. We saw the drop implementation of the guard. Perfect. I get the value by using pattern matching if let something and clone the value. which means even if the guard is dropped, the value has been cloned and returned to the call site. Clear? Okay. Make sense? Why I can't return, why I can't return a reference? Can I return the reference with read write log guard? With the knowledge that we have, right? Because guard drop हो जाएगा, reference बाहर चला जाएगा. But reference is not supposed to live longer than the guard because guard holds the reference to the data. Make sense? Okay. Now the question, ये guard में get किधर से आया? Rust में there is another trait called deref. Dereference the object, which means what was this read write lock read guard was क्या hold कर रहा था ये? Reference to the lock and non-null. Agreed? What is non-null? हमने देखा ये pointer to T. Okay. Which means if this guy implements deref, it can return T. The signature of deref is return a reference to T. Which now Rust implements something called as deref coercions, which is when you get the guard may not have get, that is all right. But does guard implement deref? Maybe yes. Let's look at it. It implements deref. What does it return? The T. What was the T that our lock was holding? HashMap. It is returning a reference to the HashMap. Okay. If it is returning a reference, can you do a get on that reference? So guard.get इसीलिए चल रहा है because get needs a HashMap का reference. Perfect. Guard implements deref, which means guard का deref call होगा. Deref से reference of HashMap आएगा जिस पे get call होगा. Perfect. Let's look at write guard. It is a lock. Okay. Leave this poison for now. Let's look at deref. It returns a reference to T. Okay. Let us also look at something called as deref mute. Deref mute. Now ask another question. How would you know deref call करना है कि deref mute call करना है? It's an error. If I just use guard, cannot borrow immutable reference, right? Okay, let me make it mutable. Okay. Does guard implement deref mute? Maybe yes. Go inside guard. Go to deref mute. Yes. What does it return? It returns a mutable reference to the T which it was holding. Mutable reference to HashMap. Great. Do you have mutable reference to HashMap to perform insert? Yes, you have. Make sense? Now our cache is holding a read-write lock which takes the ownership of HashMap. We cannot return a reference from read-write lock because lock will be dropped via guard. This pattern is called RAII. As he explained, resource acquisition is initialization. I acquire a resource, I work with it, it goes away. Clear? हाँ आता हूँ. Okay. So Ankur is asking, are the threads detached by default if they do not end their lifetimes on the closing brace of FNOK? This is FNOK. You had removed the join. Oh, okay, sure. Dekho, Ankur, okay, I'll repeat, I'll state the question. They do not end their lifetimes on the closing brace of FNOK when it returns. Ankur, it never returns. This thread becomes a dangling thread by default. मतलब ये जो thread हमने spawn किया है, I'll comment this for a while. When you say thread.spawn, Rust में क्या होता है? This thread maps to one operating system thread. ठीक है? One Rust thread is one OS thread. That means it will ask the operating system to schedule the thread. Great. This thread will eventually move into a runnable queue. Brilliant. This thread will eventually run on some CPU core. Nice. This thread will be protected by Rust compiler. How? That means, हमने देखा, if you do not move, Rust compiler will tell you, hey, you give me the cache because I don't know when I'll end. Okay. So Rust compiler has given you all the memory safety. You cannot give me an object that dies before me. Now this thread can live forever, which essentially means if you do not know when the thread ends, you can very well create a memory leak if that happens. In this example, what will happen is, let's say, it is quite possible because when you ran this program, this thread was sufficient enough to run, but maybe the thread did not get the time to run. Now, what will happen, Ankur, is we have created 100 millisecond ka duration, which is fine. Thread ran, and maybe it is running in the background. We don't know that. This thread will, the main thread which was running this test is gone. And this thread became a dangling thread which does not have a parent thread to stop it. That's it. But this thread has all the ownerships satisfied to finish its job, which is very much like a background worker. Let's say if you spawn a background worker, you can keep that background worker running forever. And only when you want to end it, you will have a handle and a signal such that the thread ends. ठीक है? संचय, when do we want to break? कभी लेने के? Okay. So अभी कुछ जो भी था, is that available? Snacks. Is the idea of read write lock, read write mutex is clear? हाँ. हाँ. So we created read write lock simple. When I acquire a write lock, it gives me read write lock write guard. When I acquire read lock, it gives me read write lock read guard. You tell me why it changed. Think again. Think again. No. Read write lock read guard. It implements deref. Does it implement deref mute? Will you ever acquire a read lock to perform mutation? Okay, that means read write lock read guard does not implement deref mute. Okay, read write lock write guard. So two references, I mean two different concepts with two different derefs. Write guard has to implement both. I mean, it is unlikely that you will get a write lock and perform reads. बहुत unlikely है, but you could still do that. But right lock guard के लिए it is mandatory to implement deref mute. बराबर? Clear people? हाँ. Correct. So I forgot your name. Sachin. The question is, we had to clone this value, which essentially means your hash map also changed. V should be clonable, correct? I cannot give you a V which is not clonable because I'm cloning the value, okay? Which means I have to clone the value. Nice. But clone is expensive, right? Or rather, it may be expensive. If the value size is 8 MB, every time you're cloning an 8 MB value, correct? What can I do is the next question. It is good, right? We can't return a reference. You agree? Because if you return the reference will live longer than the guard, which is not allowed. Clear? Why not allowed? Because guard holds a reference to the lock. Clear? And lock holds the data. समझा ना ये hierarchy? If you see the diagram, right, you have a lock. Lock has a guard, sure. Guard holds a reference to a lock. And then you have a target. Right? Target ka lifetime is the smallest, right? You cannot have target live longer than the guard. You cannot have guard live longer than the lock. Make sense? So abhi tak we cannot return a reference to the value from the get. Correct? Hence, we are cloning. Simple. We are paying the clone cut tax. There is no other option for now. We will come back. We will improve. Okay, it is 3:45. We'll take a 15 minutes break. We'll be back by 4. Okay, and then once we are back, now we'll improve our exercises wherein we stop paying the clone cut tax, right? But the remaining next 2 exercises, I would like you folks to do it. They are similar. Lock acquire karo, return something that does not pay the clone tax. Okay, I'll explain. Okay, be back by 4. Ankur, Ankur, we'll do it once people are back, maybe by 4. Hey folks who are online, we are starting. I would appreciate a thumbs up if we are good to start. Online people, okay. Before we move on, we'll first answer Ankur's question. So Ankur is saying, folks, Ankur is saying that you have a thread handle, but handle is dropped. Does that mean thread is dropped? No. If you look at this handle is a struct in Rust, great. It holds another struct, which is fine too. This does not implement drop. It is a way for you to tell the main thread, hey, I would like to wait for the thread whose handle is h1. Samjha na? Ankur, all I'm saying is, hey, I would like to wait till the thread which returned me this handle is done. There is no drop involved here. If you create a stupid thread like this, which you will never, this thread will keep on running forever till the time the process within which the thread was created is alive, right? That's obvious. Makes sense, right? Handle ka drop ho jana, that means handle getting dropped and thread getting killed are not related. Handle is a mechanism, a way, a return type that allows you to wait for the thread in question to finish. Finish what? Finish its block of code, which is your closure or lambda, whatever you call it. ठीक है? Now, in the previous section, previous stage, what was the problem with our get? We were not able to return the reference. Why? Correct. It was protected by the guard. If guard went out, the reference would go away. Rust would not allow us to return the reference. So we had to clone the value. Cloning may or may not be expensive. It depends on what the value is, right? If value is a struct consisting of a few unsigned integers, it is okay, right? Because they are just few bytes. It is as big as a string, and string may be as big as a DNA sequence, you're done. Agreed? So we should be mindful of what we clone, right? Clear, na? Okay. Our first goal is to have cheap clones, right? What is reference counting? What is reference counting? We saw that, we talked about it in bits in stage 1.
To keep track of how many bits to cover the.
Correct. In Python, when I pass a string from one method to another, you're not copying the string, you're not cloning the string. String is allocated somewhere. You're just incrementing the reference to that string. Fair? That's reference counting. Rust gives you ARC, atomic reference counting. It is reference counting. It will take a V or a T. When you clone, you're not cloning the value, you're increasing the reference count of ARC. समझा क्या? नहीं? Let's take a look. Do you see ARC here? My HashMap is a read-write lock, correct? I mean, my entries is a read-write lock of HashMap. K is the key. Nothing is changing in K. In the previous section, what was my V? It was V. Now it is? Okay. What is arc? Shall I go in? Okay. Arc takes any T which is unsized, which can be unsized, okay. Leave this, leave this. Non-null. What is non-null? You remember last time we saw non-null? Constant pointer to a T, right? Arc of inner, great, which has two references. दिख रहा है क्या? When you clone an arc, right? When you say our value is not V anymore, It is ARC of V, arc of V. Agreed? Yes, no? Okay. Which means what happens when you clone an ARC? Arc holds arc inner. Arc inner has strong reference count and weak reference count. We'll leave that for now. Okay. But if you're interested why strong and why weak, if you have an arc of type T, arc will be deallocated when the reference count becomes 0. Now imagine a linked list. A holds an arc towards B, which is the next pointer. B holds an arc towards A. Okay, khatam. A holds an arc towards B, which is the next node in the linked list. This holds a back pointer, which is again an arc towards A. So now this is a cyclic dependency, right? So you can read about strong and weak references, but for now, we'll stick to a reference count in arc. Okay? Arc holds an arc inner, fair. Arc inner has a reference count, fair. I want to look at clone of arc. Self.inner, great. This will return me the pointer, fair. This is nothing but a reference to arc inner. Nice. Uska strong reference count. Strong was a atomic U size. We'll talk about atomics a little later. And increment the reference count. You don't need to understand this for this stage. We are not cloning the object. We are only increasing the reference counter. That's it. By the way, this line is a thread-safe way of incrementing atomic U size. Atomics are undivisible. That means uninterruptible data pieces. Multiple threads are trying to increase the value. They will increase it one after the other. Take this statement with a star mark. We will explore. Is the part clear? Arc is not cloning the data. Data is stored as a... So गए क्या? Arc में how is data held? Suno. Arc takes T, agreed? That means arc has taken the ownership of T. If I am designing my arc, if I have to clone myself, I will have to clone T. मानते हो ना भाई? Because if I clone myself, who takes the ownership of T? The cloned object will also have to get T.clone. Let's say simple, I am designing, if I were to design my own arc, this is what we are doing, right? Done. I need to implement clone. क्या करूँगा? I need to return the clone of my arc. Okay. How do I do that? Create a new object. Fine. But I can't return self.t. समझा क्या? T की ownership was with my arc. Clone is only taking a reference. The only way to make this work is T.clone. Which means my T has to be clonable. Correct? So we are back to the same problem. I created my arc, which no one is going to use. Why? Because I created my arc cloning the T which it was holding, which is meaningless. So how did Rust design it? अबे reference count तो तब होगा ना जब when you are able to clone. Meaning, if you keep this as T, right? If this is just T, how will you increment the reference count? बताता हूँ. This is arc, fair, okay. It holds a pointer, it is not holding T. Remember, it is holding a pointer to something. First point. Let's look at its clone. What you said is perfect. Increment the reference count. Very nice. Done? Weak, strong, jane de. Done? What do I return from the clone? I have to create a new ARC. Okay, I have to create a new ARC. If I have to create a new ARC, then the T, which was a part of ARC, I will have to clone that T also. नहीं समझा? Where is my ARC? If I have to give you a clone, I will also have to do a clone of T, right? तभी मैं दे पाऊंगा ना. Now, the objective was to never clone T, and hence my arc holds a non-null of T or ARC of inner doesn't matter. समझा? Now, what I can do is, अब मैं खुद का ARC implement कर सकता हूँ. Increment ref count, very nice. And instead of returning T dot clone, I don't need to clone because non-null is just a pointer. You can directly take T. समझा? So non-null, which is a pointer to a T, correct ना? अपन ने देखा था. Non-null is a pointer to a T. So pointer में lifetime नहीं होती है. So you can just pass pointers across multiple objects. Hence, Rust का अगर तुम ARC देखोगे, it is holding a non-null to an ARC of inner of T. That is fine. ARC of inner will eventually hold T, correct? Which means when you clone ARC, you increase the reference count, very nice, and you create a self. It is the same pointer which is getting passed over. अबे नहीं, root object एक ही है ना. You didn't get the idea. Maybe I didn't explain it well, whatever. Take. I have an ARC. My T, first point, my T will never be cloned. Point one clear? I will increase the reference count. Perfect. This is the first ARC that I'm creating in a variable A. Okay, let's implement the clone. When you clone, increase the reference count, create, right? What are you going to do? Are you going to give a new ARC? Yes, that is obvious. Why? Because that is what clone says. But who maintains the reference count? It is not ARC, इसीलिए ARC inner बनाया गया है. Inner के अंदर का, which is same across all the clones, that is the guy, this is the guy which is holding the reference count. Make sense? ARC is called as cheap clones. You're not cloning T because we already did that, right? You're cloning cheaper objects. You're incrementing the references, right? Make sense? Why atomic? Because ARC is thread safe. Multiple threads can take ARC, keep cloning. RC भी होता है. Perfect. You remove A from ARC, what you get is RC. Reference counting, which is not thread safe. ठीक है? Now, stage 7, wherein HashMap holds an ARC of V. You have to finish this quickly. Ankur, after the exercise. Ankur, after the, okay. Okay, people, done? Done? Nothing changes too much. Self dot entries dot write lock, right? I need to acquire the write lock. What would it give me? I mean, what would these three things give me? Yes, lock result or a result of read, write, whatever, write guard, right? I do an unwrap, I insert. I am not inserting V, I am creating an ARC of. Simple? Okay. Get भी कर दिया? Self dot entries, I will get a read lock. I will do an unwrap. What does it give me? No, it gives me a guard. I will do a guard dot get. I'm not showing you this shortcut for this workshop. This is a value. Value is an option of reference of ARC of V. If let some, right? What we want to return is sum of ARC of value dot clone else. Done? Clear? We are cloning the ARC. We are not cloning the value anymore. Simple? आता हूँ मैं थोड़ी देर. In the previous example, when we were returning clone of V, if V was an 8 MB value, every time you clone, you are paying the tax of 8 MB clone. Clear? ARC is called as shared ownership. Multiple objects are owning the value, loosely speaking. Correct na? Because they are not holding T. ARC is not holding T. ARC is holding non-null of T, which is a pointer. Non-null of ARC of inner. क्योंकि वो जो काउंटिंग है वो इनर में है. क्लियर? हाँ ना बोल लो. Who owns the value here? ARC or ARC, whatever. ठीक है. Now our V is not clonable. Pehle, if you remember in the last example, our V was cloned, right? If you remember, in the last section stage, our V was cloned. Correct? So we have now removed that V colon clone. Clear? Okay. Now tell me, what is the cost of cloning an ARC? Thread safe increment of atomic references. Okay? There is still a cost because we are increasing atomics. As a group, we don't know what atomics are, we'll cover them. But there is a cost of increasing atomics, which are thread safe concepts. Okay? Or indivisible or atomic values. Right? Clear? Okay. Yes, sir. You don't. Original program was a non-thread safe cache, right? You can only measure the performance of two concepts when they are comparable, apples to apples, right? But यहाँ पे एक time you're talking about a single threaded cache, and on the second hand you're talking about non-threaded cache, which essentially means you can't really compare these two. Point one. Point two. Are we increasing the complexity? Yes, there is an inherent complexity because read-write lock owns the hash map, which owns the key, ARC owns the value. and you start to live with it, right? Point three, pura karna hai. Point three, you could question, hey, there is one read-write lock, which means when one thread is writing, others are not even able to read. Is that a performance cost? Yes. And will we improve it? Yes.
The other question is, so if I have to benchmark my solutions, if I implement it with different approaches, is there any way that Rust provides a mechanism
For
benchmarking different solutions?
benchmarking, there are three types of benchmarking: micro, meso, and macro. Micro benchmarking is for evaluating algorithms. Right? Is this algorithm better or the previous clone algorithm? Right? We will have two versions. We will implement benchmarks. In Rust, there are two crates. Rust mein libraries are called as crates. One is criterion. Criterion is more or less a standard crate for writing benchmarks. Okay. There is one more crate called Divan. You can use either of the two crates to write the benchmarks. Point one. But benchmarks alone will not help you. You need to collect profiles. Okay. So you can collect pprof profiles, which are CPU profiles using Cargo flame graph. Okay. What it will give you is a profile which will open with a flame graph viewer or a flame graph on your machine, which will tell you where is your code spending the maximum amount of time. Almost every language will give you some or the other way of writing benchmarks. Java mein JMH, Golang mein GoBench as a part of STD milta hai, which means as a part of the standard Go which is shipped, right? How you collect profiles, it can vary. Clear, people? Okay. I think Ankur had a question which I missed. Why is copying the pointer unsafe? Jaldi se dekhte hain. You have ARC, you have a clone. Clone, increment the counter, nice. This is a pointer, okay? So Ankur, this function from inner is declared as an unsafe function, right? Now why it is declared unsafe? One, basically you're storing a pointer to a non-null, right? Which essentially means anytime you're calling this function, you will either have to mark your clone unsafe, which is not possible because clone comes from an interface or a trait, or block unsafe. Anytime you're dealing with raw pointers, kabhi bhi ye aayega, unsafe will come as a gift for you. Which means, hamari next exercise mein we'll deal with raw pointers, and there also we will have unsafe pointers. Why unsafe? Because Rust cannot give a guarantee that this pointer is valid. And unsafe is an explicit way of telling to the readers, hey, Rust is not taking the ownership of, Rust is not taking the responsibility of proving that this code will not fail at runtime. Obviously, this does not mean Rust developers haven't tested it, they have, but because they are dealing with raw pointers, right? Ye raw pointer, right, is a pointer to a mutable reference to an ARC of inner. Why is this unsafe? क्योंकि अगर तू ध्यान से देखेगा, ये एक pointer है, pointer से you're creating a Rust का object, दिख रहा है? New unchecked from a pointer. How do you even know this pointer is a valid pointer? What if I pass you a garbage pointer? Hence, this guy is unsafe, the first ye wala orange, which means this becomes unsafe. We have a non-null pointer, moreover here it is. That doesn't matter, Ankur. Non-null pointer hai, that is very good, which is brilliant. But non-null ko construct karne ke liye, if you see here, non-null ko construct karne ke liye, we are giving a raw pointer, which essentially means Rust needs a way to tell the readers, every callee, every client of this method, it is a part of standard library, it is public. Rust needs to tell the callee, hey, I give you no guarantee that this pointer is a safe pointer. It's a public method, which means I can build a library on top of this, giving it a garbage pointer. So anytime you deal with raw pointers, you and Rust compiler will force you to mark that as unsafe. Okay? So that two things. One, the callies know that they are dealing with unsafe code. Rust is taking no guarantees about the unsafe code. And point two, it is a compile time enforcement. Compiler knows, hey, this is outside my boundary. Hence, the code has to be marked as unsafe. This same fn function working with non-null pointer would have needed the caller. Yes, exactly. अभी वो तू देख ले. So you see, we are calling a function self.from inner in. This is marked as unsafe. Why it is marked as unsafe? Because we are having a non-null non-null ka construction which is inside an unsafe block. This unsafe block is same as the entire function, which essentially means the callee of from pointer in needs to be in an unsafe block. Is ARC clear? Okay. First, we were cloning value. Now we are cloning ARC. Is there a way I can return a reference without cloning at all? ARC is a cheap clone. Great. It is still a clone at the end of the day, which is fine. You're increasing atomic counters, which is fine. You're paying the runtime cost because atomic increases have to be shared. Atomics hai, matlab multiple threads will increment. Great. Is there a way you can think of wherein I return a reference without cloning? अबे सोचो ना. Huh? Okay, explain.
The raw pointer.
See, what is read write? अपन ने वो guard देखा था ना, read write mutex read guard, whatever that guard was called. Read write lock read guard ऐसा कुछ. What was it holding? Not null pointer to T, yes. What else? Reference to the lock. Correct? Guard cannot outlive the reference. Why were we not able to return the reference of V outside? The guard was getting dropped. Correct na? Perfect. Okay. Take. What if we change our get? Get has to return an option, agreed? It returns a ref, which is our class, our struct, right? Which will hold a reference. Let's try and build this concept, okay? I need a ref which holds a K and a V. Okay? Fair. Okay. I am trying to adopt the idea which the guard writer implemented, writer or writers. I am trying to build my own guard. It won't hold a lock. Okay. What can it hold? I need a value. Okay. अभी सीख के आए अपन लोग. What is non-null? A pointer. a constant pointer to a V. This is not new. Yes, no? Okay. What if I hold the guard itself? I will hold a guard. Okay. Let's write it down. Read, write, lock, read, guard. Okay. What does this guard take? Give me a lifetime tick A. I will hold a reference to the lock. Achhi baat hai. Take this lifetime tick A and hold the entire hash map. Correct? Guard was any which ways holding the lock, the hash map. Yaad hai na? Guard is any which ways holding the hash map. In the previous exercise, we changed V to ARC of V. That is all right. Now, I am saying I want to build my own ref. Okay. Which will hold a read-write guard, a read guard. Okay, I'm just giving a new function which will take a value and the guard. Let's start writing our get. I need a guard. Done? Yes, no? Okay. I need to create a, क्या बोलते हैं, ref. I will do a guard.get. I have to do a get from the hash map. Let me do that first. What was the key? I'm using question mark. Question mark Rust में एक operator है, which says if the function under test is returning a result or an option, okay, and if the option is none, none will be returned. अगर option में value है तो value will come out. Same with result. Result में error है, it will be returned. If there is a value, that means it is okay, value will come out. पहले हम लोग unwrap करते थे in test. Okay, we are not doing that anymore. We are saying if the key does not exist, अरे यार, key does not exist in the hash map, directly return a none. Clear? Okay. Value मिल गई. What do I need? Ref needs a pointer. Done. I created my own ref holding the guard. Guard now holds a reference to the lock, and lock now holds the hash map. Hash map now holds the key value. Simple? Very simple, right? And now my ref holds the pointer to the value present in the hash map. Let's go step by step. Is this line clear? Acquire the read lock and get the guard. Very nice. Get the value because guard implements deref. Right, deref. If the value is not present, return none. If the value is present, convert it to a pointer. Reference to pointer conversion is safe, right? Rust knows references are legal, valid, pointer bana do. Create a ref. What will be the lifetime of ref? Can ref outlive the guard? Can guard outlive the value? No, right? Which means we are returning ref to the client. Can client get the value from ref? How? I have the value which is a pointer to a constant of V, self.value. How do I convert it into a reference? It's a pointer. I need to dereference. Done. How do I convert it? Value is a pointer, agreed? Okay. Self.value. Dereference. Create a reference. Fair? What is Rust telling me? Dereferencing a raw pointer is allowed in unsafe blocks. Rust wants the readers to either not use this library or to tell them, hey, this code is unsafe. Okay? Which means I need to mark this unsafe. But deref mein, this deref is not unsafe, correct? If you look at the signature of deref, it is not unsafe, which means I need to write an unsafe block here. Done? Okay. I think put will stay the same. Put is already done. Test should pass. Okay. Sorry. Now, people who are calling get in the cache, they are getting a ref. Agreed? The ref का lifetime किससे जुड़ा हुआ है? Think again. Ref का lifetime cache से जुड़ा हुआ है कि guard से? Correct. So ref का lifetime is associated with guard. Ref cannot outlive guard. Agreed? Guard cannot outlive lock. कैसे पता? Guard के अंदर जाते हैं. Guard cannot outlive this lock, which means the summary is when someone is using this value, right, lock is still alive. Agreed? Which means if I do this, I read the value and an infinite while loop. What have I done? Lock is with me for ever, assuming the process is alive. Correct? Which means there are 3 patterns of implementing thread-safe concepts or returning values from thread-safe data structures which are behind mutexes or locks. First, clone the value. Simple. What is the drawback? Every time there will be a heap allocation. If the V value is small in size, few integers, few unsize, U size, I size, that is all right. Second option, what is the second option? Arcv, cheap clones. You don't clone the value, you increment the references. What is the third option? Get inspired from what people have done, right? Which essentially means I want to return a reference. I can't return a reference because my guard will be out. Why not return the guard itself? Returning a guard seems weird because now others know, there is a guard, right? They are getting a guard, okay? Why not wrap the guard in a ref? I mean, name it beautifully. Which means this guy cannot outlive this. Anytime you're getting a reference, right? इस line पे, if I do whatever, ठीक है? I access the value here. Guard was acquired here. It is a read lock. Read lock is alive till the end of line 99. Agreed? As soon as you go out of 99, what will happen? How will the lock be released? Value goes out of scope or ref goes out of scope? Ref goes out of scope, correct. But ref does not have a drop, correct? Which essentially means you will want to implement drop for a ref. The drop of ref will call the drop of the guard. The drop of guard will call the drop of. Make sense? Take these are three options. Every option has a trade-off. Do you want to clone the value? Maybe yes, maybe no, depending on use case. Do you want to have an ARC? Sure. If there are too many threads, every thread may be incrementing the clone, the reference count. What if the scope of the lock is guaranteed to be small in size, right? The duration that everybody is going to hold the lock is small. Why not return a ref, right? There is a library HashMap, which is a concurrent HashMap in Rust. In fact, most of the libraries, they will return refs only because they can't clone the values. They might have specialized implement for v::clone, jahan pe they will clone. But if v is not clonable, they are left with two options. One is unsafe via pointers, wrap it into a beautiful abstraction called ref, my ref, your ref, her ref, his ref, right? Or do an ARC. Okay. So if the callee knows, hey, this ref holds a lock, then do not extend the scope of the lock, which is a general principle, right? Even in C++, what do we say? If you have multiple locks, reduce the scope of the locks. As soon as ऐसा समझ एक struct के अंदर, class के अंदर, there are two locks. You don't want to acquire two locks at the beginning. Acquire the first lock, do its job, then acquire the second lock. Two RAIs, done. Read this point. Is this clear? Why does this struct ref has a lifetime parameter? Why do we need this tick? Because the guard has a tick. Why are we storing the guard inside the ref? Correct. Because we want the value to be safely accessed. What does safely accessed mean? It should be holding the read lock. If, the lock should be alive when the value is accessed. Clear? We'll leave that for now. Are these three options clear? Okay. Any library that you take, if you see something like a ref, a guard, don't get afraid. All you have to do is gradually navigate the code. Start understanding what is tick. Why do I need tick? Okay, great. What is this? Optionally sized. What is plus? T must be valid for the lifetime tick A. Very nice. What does that mean? You should know it. Inner lock, how is it getting dropped? Go to its drop. Okay, there is an unsafe block. I'm releasing the lock. Fine. How am I dereferencing? There is a deref. Fine. These are common patterns that you will gradually adopt in your code base. And this will not be straight away, right? We did not jump to ref on day one. It's still the first day, but we did not jump to ref as the first step. We cloned the values. We reduced the cost of cloning by ARC, benchmarking, right? And then we said, hey, why not adopt ref? Our custom ref which holds a guard. Clear? Huh? Correct. Same concept. What you will do is, जैसे we return ref, you will return ref mute. That's the standard name Rust community follows. We wrapped read write lock read guard. You will wrap read write lock write guard. Okay. Like we implemented deref, you will implement deref mute. And if you think your use case needs a deref, sure. Again, learning from the library. We're not inventing our own concepts yet. ठीक है ना? अभी we are moving to stage 9. I want to ensure that our thread cache is thread safe. I should be able to move my cache to multiple threads. Remember, every thread needs to have the ownership of cache. Yes? How am I going to do that? See, everything is same. हमारे पास ref है, guard है, value है, ref का new है, deref है, which is fine. But there is a test which says I will create a cache and I should be able to move the ownership of this cache to multiple threads. दिख रहा है ना? I have a cache. I am cloning the cache. Only after I clone, I'll be able to move the ownership to multiple threads. Agreed? एक ही thread को तो I can't move to multiple threads. Only one thread can take the ownership. But cache cloning is expensive. What will you do? Correct? So let's do it together. There's nothing new here. You folks have already done that. See, new is returning an arc of cache. New का signature change हो गया. What was the earlier new? Older new. It was returning a cache. Now we want to have shared ownership. क्या करोगे? First, let's construct the cache. Done? I want to return an arc of this. Done? Visible? How will you implement put? Nothing changes. You take the right lock, unwrap the guard and perform an insert. Simple. Now read. We have just implemented this. Self.entries. You have a guard. I want the value out of it with a question mark. Okay. And I want to construct a pointer and finally return a ref. The only change is, instead of cache, we are returning a shared owned cache. ARC of cache, right? We are not asking people, hey, take the cache and create an ARC outside. Our API itself is intuitive, saying my cache is thread safe. You can clone the cache, create multiple instances if needed, and give it to multiple threads. Okay. What that means is, I will create a cache, agreed? 1 to 10, I will loop from 1 to 10, map, I will get a counter, I will create the clone of the cache. Cache.clone is ARC clone. I will get a clone. How many threads I am creating? 10 threads. And each clone will get its put method. Correct? Put get जो भी है, which essentially means simple. If an object का ownership has to move between multiple threads, the object has to return an arc of type T. where T is the object itself. Samjha? So you should learn, or rather, you will eventually learn to differentiate when arc makes sense and when a custom ref would make sense. Yahan pe we don't want to create a custom ref, right? If multiple threads need cache, that means they need to take the ownership of the cache. Cache has to be alive till the time thread ka closure is alive, right? Which means cache has to be clonable. But cloning the cache is expensive, so you're back to the second point. Create an ARC of cache. Clear so far? What is ARC? What is ARC? अबे अभी तक तो हाँ बोल रहे थे. What is ARC? Atomic. It's okay you don't know the full form. That's all right. It's literature. It is a reference count which increases atomically. It is okay we don't know what is atomic. That's all right. Fair? With ARC, do we clone the values? We increment the counters. Very nice. But ARC of clone, ARC ka clone, does it hold the T itself? That means ARC of T, or does it hold something else? Non-null pointer to ARC of inner. Why does it need ARC of inner? Why does it need ARC of inner? Acha.
To avoid access to
Agar, correct. If the counters, strong and weak counters were in ARC, we have already cloned ARC. So the problem that he was saying, समझा ना, ARC किया, उसका क्लोन करोगे, ARC के अंदर counters होते तो क्लोन चला गया, counters भी चले गए. Now how will you increment the counter? You need ARC of inner, or a beautiful name which holds the counter, and you don't clone ARC of inner. So non-null of ARC of inner of T. समझा? Now what? I have a my ARC. I have to clone, which means I have to return a new ARC. Very good. My ARC data mein I will put self.data, which is all right. Now I'm cloning the ARC, right? If count are in my ARC, वो तो clone के साथ चले गए ना? Then how will you increment the counts? Correct. Two different clones have two different counts, and you enjoy, right? So now when I clone, right, I will give the data, which is fine. Before that, self dot क्या था यार? Self dot inner. Self dot inner dot or the inner is at ठीक है चलेगा. For now, that's okay. You can always construct a pointer out of it, right? All we are saying is my ARC cannot hold this counter, because if my ARC were to hold the counter, you clone the counter is gone with the clone. What you need is an ARC of inner. Inner, केवल नाम ले रहा हूँ, it can be anything. Inner is the guy that will hold the counter or counters, ठीक है, along with the data. यहाँ पे data नहीं जाने दो. And what you have is a non-null pointer to my ARC. Why non-null? Because when you clone, pointers को clone करने का जरूरत नहीं. You just pass that pointer across. Where? This pattern, some literatures call this as handle body pattern. This is the handle, right? Handle is the guy that does jobs like clone, and this is the body where your actual content, सामान यहाँ पे रहता है. ये we'll see when we implement thread का cache को, how do I stop the cache, right? उस time पे we will talk about this pattern one more time. Fair? Now, do you understand why we need, or why ARC needs ARC of inner? Tell me the problem with our thread safe cache. I will open our cache. What is the problem? The problem is not syntax, tests are not passing. That's not the problem I'm talking about. Explain. Perfect. Correct. So let's say there are 20 threads which are coming. 20 is a small number, sure. Thread 1 creates the write lock. Rest everybody is waiting. Arey write lock free kar, right? Second thread ka chance aega. The moment second thread acquires a write lock, even readers are waiting for the writers to finish. Okay. What do you do? Start with something simple. That's all right. You can provide an update method. Update will take क्या बोलते हैं? Update will take the write lock and do the job. job that you have to do will come as a closure or lambda, correct? What if I give you a lambda which takes 5 minutes? समझा ना? You will have to take update का second parameter. You can't just say key and value दे दो, I'll do an update. What if I want to do in one log multiple updates? Anything, which essentially means update might end up taking a lambda or a closure. Which essentially means if your hash map holds 10,000 keys, you have 10,000 locks. But you're close. Correct. Have you heard of sharding partitioning? What is that? Yeah, what is that?
This is basically you allocate a section of the hash map to one single thread. That is, a thread is responsible for its own part of the hash map. No other thread can touch that area. So if any request is coming to any keys that is owned by that thread, only that thread will operate on it.
9. See, when we talk about sharding, in distributed systems, sharding means distributing the data across physical nodes. Literature-wise, sharding and partitioning is used interchangeably also. If you read Kafka ka source code, you will find the term partitioning, which means if a topic has 10 partitions, distribute them across, let's say consumers, brokers, whatever. When we talk about, let's say, sharding or partitioning in locks, right? Current situation is one big lock over hash map. Agreed? One thread acquires the right lock, other threads are waiting. What if you create buckets of hash maps, right? Imagine buckets as arrays. You have 256 arrays. Let's say 256. Each bucket holds a read-write lock of hash map. Good so far? You have buckets. Each bucket has a read-write lock of hash map. Clear? Anytime a key comes in, take the hash of the key. Simple. Once you take the hash of the key, modulo number of buckets. Modulo 256 will give you a value between 0 and 255. Perform a write into that bucket, which means acquire a lock of that bucket or a shard. What we have done is distributed locks. There could be a problem. अगर बहुत सारी keys आई, if your hashing algorithm is bad, most of these keys could fall in the same shard, which means all these keys or threads would want to acquire a lock on one shard. Clear? But the idea is, instead of having one big fat lock over the hash map, have n number of hash maps, n number of read-write locks. Distribute them in a concept called shards. How does that look? Nothing fancy, right? See it. Can you read it for me? Huh? Vector of read-write lock of hash map of KV. What is vector? Something like an array list. It's heap allocated. What is each element of vector holding? What is vector of 0? Read-write lock. What is vector of 1? Read-write lock. What is vector of 2? Read-write lock. What is vector of 255? Read-write lock. When the key comes in, what will you do? I need to identify, अरे key को कौन से shard में डालूं? कैसे करोगे? It doesn't matter कैसे करोगे. The idea is get the hash of the key and modulo number of shards. That's it. And you can always change the hashing algorithm, right? That's the general idea. Even HashMap does it. How is HashMap implemented? Buckets, each bucket has its own data structure. In Java, it is a red-black tree or an AVL tree. In Golang, each bucket again is an array of fixed size. When a key comes into a hash map, it calculates the hash, modulo the number of buckets, and writes the key value within the data structure of that bucket, right? In HashMap, everywhere, they resize the HashMap. They can increase the buckets. We will not increase the buckets, right? You get the idea? Instead of one big fat lock, we are having shards. Each has its own read-write lock. Anytime the key comes in, we identify which shard you belong to, acquire the lock on that shard and do the job. Job remains the same. Insert hoga by taking a lock on a shard T. Get hoga by taking a lock on a shard T. How do you identify the shard? By taking hash of the key modulo number of shards. Simple? Okay. Tell me, how will you do this? कैसे करोगे? Let's first create, नहीं. Let's first implement put. We'll do new later. Jaldi. Okay. There is a shard index. Okay. See, shard index is only taking a reference to a key. It is not taking the ownership. Self dot shard index, pass a reference to a key. Done? Now what? From the shards, at this shard index, acquire the right lock, perform an unwrap, do an insert. The same thing that we did. Now it is at this, the lock within this shard. Yes, no? Tell me, get. You got the shard index. Now what? Done? Same idea, nothing is changing. We are just sharding, distributing the locks. Make sense? Okay. The only thing that is left is construction. I want to create a vector of n read-write locks. Okay. Done? Iterate till the number of shards, 0 to number of shards, or 1 to equal number of shards. For every counter, create a read-write lock. Within read-write lock, wrap the hash map and then collect. You can imagine this as a for loop also. That is all right. Nothing changes. Will the tests run? Done? So now to the question that he had asked. Can I improve the performance? Yes. So when we were at global lock level, right? We started improving that only within its own scope. Kaise? We started with value clone. We realized that's not a good idea. Okay. We implemented ARC, where our benchmark said on increasing the number of threads, atomic counters are increasing, there is a cost to it. And we experimented with ref. We would have picked one option, great. We would go ahead with that option. First level clear? Second, we increased the number of threads, we realized one global lock is a problem. My readers are waiting for my writers. My reader wants to write key Sarthak. My writer wants to write key E6 data. They fall in different buckets because I know it. Yet I have a problem. It's a simple logic, which essentially means the minimal change that you could do is implement a vector, distribute the locks, right? In distributed systems, when we say, hey, let's increase the number of shards, that means we are increasing the number of nodes who will hold the data belonging to the shards. Increase the locks. When the threads perform write operations, you identify which shard to acquire a lock on. When you perform a read, you acquire lock. It could still be skewed. We are not saying skewness is zero. ठीक है ना? Conflict अभी भी हो सकता है. Make sense? We are still returning ARC, nothing has changed. So we solved global lock, great. We'll skip TTL, but if you after this, if you're interested, go ahead and do the TTL. देख कैसा है ना कि typically I have not seen OSs impose limit on the number of locks, right? For example, there is a limit on the number of file handles, etc. But as an implementer, you can keep an upper limit on the number of shards that the user can provide, which essentially means I will not allow more than 1024 or 2002 ka power. Why 2 ka power? Because I did not implement 2 ka power. Why 2 ka power? Because the modulo operation that we are doing, that can be converted into a bit shift operation. Barabar? I mean an AND operation. N and N minus 1. But if you find that an OS imposes a limit on the locks, which is fine, even I'll have to check that, then we could always say, hey, number of shards cannot go beyond N. But I don't know about that. Let's assume you have to implement statistics in your cache, meaning how many GET requests came in, how many puts came in, how many cache hits for keys which were found in the cache, how many hits were found, how many misses. How will you implement these statistics? Jaldi. Okay, nice. So you will create a struct called, let's say in the lack of better terms, statistics, okay, and create a counter. Which counter? Read write lock of U size? Something of this form? Okay. Sure, sure. This is one idea, right? I can always have read-write locks or mutexes. One for each counter, one for each statistic type. Agreed? Would you like to have this or? Sure, we can use atomics. First, tell me the problem with this. Speculation. It's a speculation. You prove it to me. Why would it impact the performance?
Because before you actually, I'm assuming this function will be called immediately after your get or put. So there's a delay for the request to go back.
What kind of delay are we talking about? This part of the code takes a write lock and does a dereference plus 1, right? Dereference plus 1 is addition, nothing fancy, but write lock is what you're saying is expensive.
So that can be expensive because a lot of threads can be.
Correct. So if you hold one read-write lock per property, does not matter. Let's say your cache becomes popular. Too many threads are hitting, gets, puts, whatever. For every operation, you're incrementing the statistics, right? Which means you're taking a lock. Every thread might be trying to acquire lock on the same statistics. I don't know that. Every time, Rust may thread maps to an OS thread, which means every time thread wants to acquire a lock, OS will see if the lock is not present, it will, if the lock is not available, it will deschedule the thread. Okay. What does that mean? Thread would be moved to a waiting queue. After some time, that thread will become ready to run. It will come to runnable queue of the operating system. And then it will be scheduled to work on one core, right? This is expensive. If the number of threads, if the contention for a lock amongst threads is high, that means too many threads. But this is one design, and he is right. If there are too many threads fighting for it, you have a problem. What can you do? Ultimately, you need the aggregated statistics. I don't need shard level. Shard is an internal design. It's a decent idea if you're saying have it at the shard level, but I need it aggregated. If you have a log for each shard, you will acquire a log for the statistics, great, which essentially means you have shard level statistics, very nice. When I tell you give me the complete statistics, सारे shard पे you need to acquire log. Sorry. What does that mean?
Whenever we get output operation we do, we update the information with the help of thread. Do not block this operation, just create the thread and just
I need a guarantee that your stats are getting updated. You're saying you do the current operation, which is put, and then what?
inside the put I will do like set the detail like save something.
Correct. So what he's saying is, the other option is, in the put operation, do your put, and after the put is done, send this information to maybe another thread, right? Which takes this message over a channel. Rust gives you channel, Java has queues, right? Array blocking queue, linked, concurrent queues. That is also a decent design, wherein you're sending the message to a channel. No, channels are implemented again. There are two designs, right? In Java, array blocking queue will need a lock. Concurrent linked queue, it's a linked list based queue. It does not need a lock, uses atomics. In Rust, channels use atomics. They don't use locks. But the bigger challenge is, if the number of threads increase and a lot of puts are coming, you're saying I will send these messages to over the channel to a target thread. You need to decide the size of the channel. Channel cannot be unbuffered. Unbuffered meaning एक time ऐसा आएगा out of memory चला जाएगा. How will you decide the right size of the channel? Technically, you can't. How do you know the fixed size? 1024 is also. Every put is causing a message, right? This message is going over a channel. You need to know the size of the channel, which means you should be able to, you should always be knowing how many puts are going to come in per unit time, how many gets are going to come in, how many other things are going to come in. All these things will result in one message to the channel, correct? And there is a single consumer of the channel currently, which essentially means size of the channel is size of all these messages plus some buffer, right? Because I might undershoot, which essentially means channel is a good design, no doubt. You will have 2-3 things to think. One, how do I estimate the channel size? It can't be a random number. Is the channel consumer a single consumer, or do I have multiple threads जो channel से round robin तरीके से read करते? If you say I have one consumer, it is a back brush. Thousands of puts आया and it is taking some time to perform writes. But that's a fair design. You can have channel between puts and your statistics update. What else? How does ARC increment its counter without logs? Correct. So this is the topic of atomics. Okay. What is an atomic? Sorry, repeat that.
Basically, it's a lock at the lowest level possible at the CPU level, and this is lock applied using an assembly language on that end. I don't know exactly.
You can't apply a lock on a variable.
Not variable, but on the register, right?
You can't apply a lock on the register.
I don't remember the assembly code, but in the assembly code, when you do an atomic operation based on the CPU architecture, there's a lock being used at the lowest level possible.
Sure. Atomics are indivisible operable units, which means when you say atomic U size, yeah, atomic I32, which is a 32-bit integer. Any operation will be either completely done or not done. That's what atomic is, right? Which essentially means when one thread is writing, other thread will not be able to see unless the first write is done. This happens, like he said, via CPU instructions. Some processors, I think x86 में अगर आप assembly instruction देखोगे, तो assembly instruction is xlock, a lock based instruction. ARM has some other instructions for performing atomics. ठीक है? Anytime you perform operations on atomic, let's say I want to increase the counter. यहाँ तो one thread is increasing the counter, other thread is reading the counter. The other thread will not be able to see half incremented counter, right? यहाँ तो पिछला value दिखेगा, the value before the increment या after the increment, ठीक है? Now, atomic is a complicated topic to understand. I'll try and see how I can explain and what. Can you read this code quickly? I have a function which takes A and B. What is A? A mutable reference to? What is B? Sorry? Okay. I am dereferencing A, incrementing A by 1. I am dereferencing B, incrementing B by 1. I am dereferencing A, incrementing A by 1. Okay, nice. Will the compiler and the processor execute it in the same order? Sorry, who says that? हाँ, बताओ. See, two things. the order in which you write the code is not necessarily the order in which it gets executed. Compiler might look and say, "Arey, A is incremented twice, let me change the compiled instruction to A plus equal to 2 and B equal to 1, agreed?" So your code has changed. See, the output has not changed, only what gets executed has changed. Where? Is the order guaranteed to be the same? Why? What is out of order CPU? B plus 1. See, your processor might see, "Arey, B ko I have to increment by 1. It's an instruction, agreed? A ko I have to increment by 2. Great. Compiler might see, "Arey, I already have A in the register. Sorry, I already have B in the register. Let me execute B first. I will execute A later." Make sense? There is no guarantee that your instruction within a functions will be the same. Okay. ये foundations है atomics. Clear है? Okay. Now we are on atomic. Okay. I have an atomic I32. There is one thread which is saying, thread A, which is saying, I want to add 5 to X. Then it is saying, I want to add 10 to X. Okay. X is one variable. Great. Another thread is loading X. What? Now tell me, what is it that the other thread can see? क्या दिखेगा उसको? Tell me the output. Will the value 1 be 5 and value 2 be 15? Okay, why? Okay, let's assume thread 1 has executed first. Now what? A has finished, nice. That means value of X should be 15, which means thread B should ideally see 15, 15. One possibility. Is it guaranteed to see 15, 15 if thread A has done? Yeah. Okay. What is this relaxed? With atomics, right? In languages like C++ and Rust, we specify the memory ordering, which establishes happens before relationship, right? Did this happen before this? Okay, I'm trying to load X. I'm a thread, you're another thread. I need to form a happens before with you to be able to see what you wrote. Fair? Relax does not form any happens before relationship per se. Okay. Relaxed memory ordering in Rust says, the memory model is taken from C++, it says, I can return any value of the variable under subject or in subject, which is in accordance with memory order or modification order of the variable. What is modification order? Changes in the values of X. X का first value क्या है? 0. What is the second value? अच्छे से देखो. Second value? 5. Third value? Okay. I'll ask again. First value? 0. Second value? Why can't it be 10? Who is telling why can't these two instructions be reordered? Right? They can be reordered. if they can be reordered, right? Naturally, my memory order is 0, 10 and 50. My other memory order is 0, 5 and 50. Which means when another thread loads the variable, it can see 0, okay? It can, so one thread might see 0, 0, 0, even though the value has been written. Other thread can see 0, 5 and 50. Other thread can see 0, 5, 5. Other thread can see 0, maybe 15, 50. It cannot see 0, 15 and 5. Any possibility from the modification order, MO is modification order, वो चलेगा in relaxed memory ordering. समझा? Now, let us assume you have two atomic variables, data and logged, okay? Thread A stores 42 in relaxed manner, okay? Thread A stores unlocked in release order. We don't know release yet. Thread B tries to load logged in acquire order. When it sees unlocked, it tries to load क्या बोलते हैं data को in relaxed order. ठीक है? Clear है? Two variables, data and logged. Data is always operated in relaxed memory ordering. ठीक है? Okay. What will be the outcome of assert EQ? That means, will it always pass? Will it fail? Can it fail? Huh? Depends on? Fair. देखो, release memory ordering happens with store operations. ठीक है, जब भी store करते हो, you can specify release ordering. Release says, ध्यान से सुनना, any thread that forms a happens before relationship in acquire order with me, if I am the thread that did a store in release order, right? Any thread that forms a happens before relationship with me by performing a load in acquire manner will see all my changes that had happened earlier. अभी देखो, डेटा को 42 लिखा गया in release order, okay? Logged को unlocked किया गया release तरीके से. Fair, यहाँ तक clear? Okay. दूसरी thread आई. The other thread loaded the value in acquire manner. It kept on loading, if को while समझ लो, whatever. It kept on loading until it saw unlocked, which means happen before relationship is done with the thread that's stored in release order. ठीक है? Which means now this thread will see all the changes written before ये store. Make sense? Yes, no? See, if this thread sees unlocked, correct? इस thread को कभी तो unlock दिखेगा. Assume कर लो if की जगह while loop. That means this thread is forming a happens before relationship with release, which means thread B will see all the changes that have happened to any writes written before the release store. For now, nahin. For now, you need to understand only release and acquire, relaxed and acquire release. Now explain me this code. जल्दी. We have a concurrent stats counter. Entries is an array of atomic U size. On a 64-bit machine, atomic U size is 8 bytes. Okay? Clear? We are saying there are 4 atomic U sizes. Your original idea was let's hold 4 locks. I've taken your idea. Instead of 4 locks, 4 atomic U sizes. Simple? Okay. When we have to increment self.entries.stats type, what is stats type? It is an enum, which is fine. Dot fetch add. Increment the counter in relaxed order. That means if somebody tries to read it in relaxed order, there is no guarantee they'll see the updated value. Mante ho na? Aaya na? But that looks like a decent design, starting point, right? We can have array of atomics. Every time we have to increment something, find the index of the atomic, fetch add. Simple? Yes, no? Okay. I have a concurrent stats counter. I have to implement this. What do? I have to increase whatever is the stats type by this count. Looks okay? If you need the actual, you need some happens before guarantee, what you could say is, I want to do a release ordering. Anyone who reads it will do an acquire load. Simple? Yes, no? I'll mention one point. यहाँ पे relaxed ordering चल सकता था. Because you will have to look at the underlying operating system to see if they support relaxed ordering or not. Most of the operating systems, most of the processors will just say, hey, I don't support release ordering, I don't support relaxed ordering, I'll convert it to acquire release manner. Okay? So, हो सकता है, even if you write relaxed, it may translate into an acquire release kind of a relationship at the processor level. Okay? Clear so far? Stats counter is usually simple. We maintain stats and we increment them atomically. Clear? Yes, no? Have you heard of a protocol in processors called MESI? M-E-S-I. What is it? Cache coherence, nice. What is it? See, when a processor loads a value from RAM, does it load a single value? Then what does it load? It loads a cache line. Typical size of cache line is 64 bytes. It's not fixed. Which means if a value falls, in our previous case, entries was an array of atomic U size. Atomic U size on a 64-bit machine is 8 bytes, which means 8 multiplied by 4 is 32. 32 bytes will fall in one cache line. Agreed? Yes? Okay. MESI says a cache line can be either modified, exclusive, shared, or invalid. When a thread running on a core 1 modifies a cache line, the state becomes M. Okay? Which means every other thread that was holding the cache line, why? Because it was also working, it will have to reload the data from RAM. Okay? HMPG, hits, misses, puts and gets. We have 4 atomic U sizes, agreed? Okay. All these 4 lie in one cache line. ठीक है? मानते हो ना 32 bytes है, your cache line is 64 bytes. Okay. There are 2 threads or 2 cores. On core 1, I modify hits. On core 2, I modify misses. What is going to happen? What contention? Correct. Which essentially means thread running on core 1 will fetch the cache line. Thread running on core 2 will also fetch the cache line. Thread running on core 1 will modify hits. Hits is within that cache line of 64 bytes. It will mark the cache line as modified. It will send a message over message bus. अरे ये cache line जिसका address was this is modified. Every other core is now forced to fetch that cache line. This is called as false sharing. To avoid false sharing, you need to ensure each atomic U size is 64 bytes in size. Can you do that? All we are saying is, I want to have a counter, right? Concurrent stats counter which has a counter. Counter has atomic U size followed by 56 bytes of padding. Why? Because 8 bytes for atomic U size. एक counter 64 bytes ले लेगा. Now, when the thread 1 modifies, it modifies its own cache line. Thread 2, अपनी cache line. Done? So, anytime you're working with atomic values, in an array especially, contiguous level, the first thing you will have to think of is false sharing. ऐसा तो नहीं है my multiple atomic values are lying in one cache line and one thread running on core 1 is trying to modify just hits while the other thread running on core 2 has to load the other cache line. Simple? Now instead of building your own counter, you can use in Rust crossbeam करके एक crate है. Crossbeam gives you a utility called cache padded. Same padding, but it ensures it does not just build for 64 bytes ka cache line. That's it. So all we have done is we have created a tuple struct, and we have 4 such counters. Sorry? Like one is you prove it is necessary, right? वो समझा ना, 4 atomics lie in one cache line. हाँ, if the atomic size is same as cache line size, you don't need to worry because 64 bytes are occupied. But what atomic will take 64 bytes? अगर 32-bit machine है and your cache line is still 64 bytes, it is very very unlikely कि तेरे को कोई एक ऐसा data type मिल जाएगा जो 64 bytes occupy कर ले, ठीक है? Which means you need to pad. But how will you prove there is false sharing is a different topic altogether. But you understood the reason why you need to pad, because each atomic should lie within its own cache line. Two threads will hold the same cache line and they should not play ping pong with each other. इसने hits को modify किया, उसको misses को modify करना था, फिर भी उसको पूरा का पूरा cache line load करवा दिया तूने, वो नहीं होना चाहिए. How do I? हाँ.
I was not aware of such a topic exists. I just that's just based on economics and without planning. How can I find out?
Take your processor, you load the data from RAM. Data does not directly come in registers. It flows through caches, L1, L2, L3 caches, right? Some machines also have L4, wo jaane dete. When you have false sharing now, there is a very common thing that happens on your machines. You will update hits, दूसरी thread को क्या करना पड़ेगा? Louder.
It has to
Reload the data, okay. Your data, that means दूसरी thread updates hits, पहली वाली thread को क्या करना पड़ेगा? Reload करना पड़ेगा. Which means when there is false sharing, especially your L2, L3 cache, L2, L3 CPU cache misses will shoot up. ठीक है? If you are working on a Linux machine, you have a tool called perf. So perf में you can record the measurements and you can look at the statistics. Perf stat -e cache -misses and your, let's say, a benchmark. Benchmark will be your executable. तेरे को एकदम से दिखेगा अरे misses. First hint should be I've written a code which deserves Nobel Prize, but somehow it is missing something, right? हाँ. Okay, good point. Transparent macro वही करेगा, which it'll just enforce कि ये जो counter है, counter का layout is same as the layout of the underlying type. It guarantees कि layout same है. याद है अपन कैश की बनाया था, कैश की में भी मैंने क्या बोला था, memory layout will be same as that of string. Transparent is a way to force that layout. Clear? Okay, I think we'll pause here. I'll show the complete implementation just as a quick summary to you folks. This is in stage 14. It is all implemented. Okay, let's start reading it. We have a cache which works on KV, great. K is hash plus EQ. Key को clone इसीलिए करना पड़ा था because I skipped one topic which is TTL. I have to add key in TTL also, which means now key needs to be here also, there also. I decided to keep key as clonable. When you implement your cache, you might say, "Nahi, I don't want to have keys as clonable. I will take ARC. That is all right." ये अभी थोड़ी देर होल्ड कर, वैल्यू को भी होल्ड कर. First thing, stats counter simple. It is the same that we saw. Stats counter has your hits, increase, hit ratio, and atomic operations like fetch, add, and load. I have a cache, very nice. Cache creates. We saw this pattern, right? ARC of inner. ARC of inner क्यों चाहिए था? ARC of inner needs non-null. I mean, non-null of ARC of inner of T. Why did we have to create ARC of inner? Because we wanted to maintain weak and strong counters. Agreed? अगर ARC में होते तो वो तो clone के साथ चले जाते. Okay. Here, what I wanted was my cache to be able to shut down. Cache को shut down करना है, correct? हमने पिछली एक्सरसाइज में कैश का ARC रिटर्न किया था. We had returned an ARC of cache. Agreed? Okay. If I provide shutdown in cache itself, what will happen? every thread who has that handle of cache, which is the cloned cache, right? ARC of cache clone ho gaya. They all will be able to invoke shutdown. From first stage, we have been saying type safe APIs, right? I only want one master thread, let's say a master thread in the lack of better terms, to be able to shut down. Rest everyone else, which is the thread, they should be able to operate, correct? We bring that pattern here, cache inner. Cache inner is the same thing that we implemented. इसमें अपने पास shards हैं, number of shards हैं, and are we shutting down? Where the code that was there with the cache has now come to cache inner. Clear? How do you implement shutdown? You take the reference. You don't take the reference. You take the ownership of the cache. ठीक है? That means एक बार cache पे shutdown call कर दिया, that cache variable should be unusable. Make sense? Again, type safe APIs. Once you call shutdown, I don't want anyone else to do anything with the cache. But cache inner is clonable. दिख ही रहा है वो यहाँ से, correct? ARC of cache inner, which essentially means it is quite possible master thread might have called shutdown other threads जिन्होंने cache inner को clone किया है. They might still be doing put get agreed, which essentially means I will have to pay a runtime cost, saying if the cache is shutting down, then whatever, return error, do not do this operation, etc. So this is the model that we took from ARC inner. ARC had to have inner. Why? Because ARC clone किया तो वो counters चले जाएंगे. So if you look at clone for cache, what are we cloning? We are cloning the inner, we are cloning the stats counter and leave the cleaner for now. Which essentially means cache के अंदर जो inner था वो clonable है, correct? That inner is ARC. But shutdown is only available on parent cache. Which means एक बार ये thread ने shutdown कर दिया, this shutdown, can I use cache again? It's a compile time error. Cache has been moved, the variable has gone out. Clear? So this pattern is handle body pattern. Where did we take it from? From ARC and its inner. Rest everything is the same. We just added a few more quirks. We are waiting for our cleaner thread to finish. That's okay. The most important idea is to be able to understand, hey, my cache should be the master of the operation, which is shutdown. My inner object is the one that gives me get put phalana, right? I don't want my inner to call shutdown, which means फिर तो 1000 threads है, 1000 can call shutdown. One shutdown and then a runtime cost will be paid. Why? Because a put operation might still be in progress when the master called shutdown. Fair? Make sense? ठीक है. Any questions? Cache inner, right? Cache inner holds a KV, correct? We want cache inner for holding KV, जहाँ पे K and V should go amongst threads. That means I should be able to send K between threads. मानता है? If it is a string, I should be able to send the ownership of string to other thread. तो Rust में there are marker traits. send and sync, right? Send ये बोलता है you can transfer the ownership of the subject under question to another thread. Sync ये बोलता है multiple threads can have the reference to the subject under test. Read write lock. अपना यहाँ पे कहीं पे read write lock होगा ना? ये दिख रहा है? This block is saying it is a hint, no, not a hint. It is an instruction to the compiler कि read write lock is a sync. इसका मतलब multiple threads can take the reference to the same read write lock, which is true, right? One thread read locks. 1000 threads can have the same read write lock का reference. Reference कहाँ होता है? Guard में होता है. That is fine. So sync ये बोलता है multiple threads can take the reference. Send ये बोलता है कि multiple the type T in question can be sent to multiple threads, right? They may or may not coexist depending on the use case. तो यहाँ पे if you do not implement कहाँ गया? If you say I have a cache, which is very nice, cache has a cache inner. Okay, what is inner? Inner same concept है जो हम अभी तक बनाते आए हैं, right? Inner में से भी ये हटा देता हूँ. Cache, inner, cache, gone. I think send and sync is gone for K में से हटाया, K में से हटाया, K में से हटाया, K में से हटाया. Done. Right? Which essentially means if your inner forces, that was just, if there were time, this was just to tell कि if your inner is forcing KV to be send sync, this will boil up, which we have already covered, right? But this example में you can take K and V में से I think send sync, maybe static also out. And if there is an error, bring it back. Huh? No, these are marker traits. You don't need to implement them. You just have to say K is send and sync. Rust में all types are send sync except RC, ref cell and cell. I think these are the three जो thread safe नहीं है. They cannot be shared across multiple threads. RC is a reference count, not atomic reference count. So two threads can't have the reference to RC, right? First, don't implement, right? As you grow forward, compiler errors will start appearing. Hey, this type should be send, assuming you're building a multi-threaded app. And then you start adding send and sync, obviously with reasoning. यहाँ पे it wasn't for that purpose. Do people have the energy for 5 more minutes? I think किसी ने Thanks, Ankur. ठीक है. अपने जो generic types थे, I think you had raised a point. Why are they sized by default and not ulta, right? That means as a language writer, why did they say all my generic types are sized by default? When you see a signature hash map of KB, how do you think Rust implements generics at runtime? Correct. Rust has a concept called monomorphization, which means simple. I have a struct A which has a hash map of KB. Ignore all of this, right? If you look at the client of A, okay, what we are saying is I want to create an A जिसमें hash map is a string, right? Rust इसको compile time पे ही एक hash map generate करेगा. I mean hash map का code generate करेगा tailored for string. समझा? That means Java में कैसे होता है generics? Java में generics are removed at compile time, right? It is only a compile time gate. Rust में if you see, or maybe if you look at option, it is generic, right? Now, when the compiler sees, there is a usage of option meant for I32, compiler will kind of generate. This is only sudo, okay? Option of I32, sorry. Option I32. समझा? This process is called as monomorphization. Okay. Name is fancy, that's all right. How does it help us? If all the generics are by default sized, right? Which essentially means जब generics monomorphize होंगे, compiler would almost always be able to decide the layout for the types. क्या ये type का size मेरे को compile time पे पता है? अगर पता है, I can do stack allocation, avoid heap allocation, right? If all the generic types were unsized, optionally sized, Rust में 3 optionally sized types होते हैं, एक str, right, without %, एक slice जाने दो, और एक dyn, dynamically dispatchable concept. अगर सब कुछ optionally sized होते, compiler optimization opportunities on layout, ये object stack पे allocate करूँ कि heap पे करूँ, वो सब miss हो जाता, right? For example, if you take a hash map, अगर hash map में compile time पे पता चल जा रहा है, अरे ये जो hash map है तो strings के लिए call हुआ है, which means strings have to go on heap. Great. The references or the pointers to the strings are on stack. Similarly, if at compile time it is known, I am only dealing with, let's say, I32s, all of them lie only on stack. I don't even have to go to heap for holding those values. Samjha? Hence, by default, generics and monomorphization lead to, the idea of monomorphization takes you to making generic types sized over unsized.
So here
No.
stack memory, right? Like you cannot go beyond by this particular size for the stack locations.
जो stacks होते हैं, हर language में stack का size होता है, right? If the stack size is let's say 8 MB, right? That essentially means पूरे stack में you can have 8 MB. Now, what that also means is stack में कौन से objects जाते हैं? जिनकी size is known at compile time. Do you think the size known at compile time will be 8 MB? Never, right? अगर तू देखेगा एक string heap पे गया तो जो variable है let's say A is only 24 bytes. It has to go a long way to fill the stack, right? Which can very likely happen only in a recursive function wherein you go out of stack memory. Otherwise, it will never happen. नहीं मैं बोला ना जेनेरिक नहीं आई डेंट गेट द वापस से बोल बट तेरा अंडरलाइंग डेटा स्ट्रक्चर हमारे कैश में हमारे केस में कैश वाज द डेटा स्ट्रक्चर दैट वाज जेनेरिक करेक्ट if you're designing only for I32 F32 whatever then you don't need to make them generic right but let's say you're saying I want to make generic only for numbers then there has to be a common trait number which will be implemented by all I32s F32s I size U size etc समझा which means तेरा data structure will be generic over number. The moment you have generic over number, that generic by default is sized. बात खत्म. So Anko, that's a very wrong theory, huh? If you believe contention should be less, it should be affordable, that's all right, which is fine. But you have to understand when a thread acquires a lock, right? If the thread cannot acquire a lock, the thread is going through a long process. It will be put in the waiting queue. After some time, it will move into a runnable queue in the operating system. Now the challenge starts. पहले जो thread थी ना, that was running on core 1. Now that thread could be moved to core 5, which essentially means the entire work done by the thread on core 1 is gone. What is that work? Loading whatever, majority of the data from RAM to L3, L2, L1 cache to registers even, all of that is gone. So thread को core 3 पे move किया गया, core 5 पे move किया and start all of the work. Never will you have a case where the contention is high despite increasing the number of locks. You will never be able to match the performance that you could get with atomics because atomics में threads are bound to the core. They are never leaving the core. That is why your Scylla DB or Scylla, however you pronounce it, it implements thread per core model. Every thread is bound to a core and there are no locks. Threads only work on the core on which they have been attached to. So maybe read it. Quickly on HashMap. See, we are inside HashMap, okay? I mean, we will be. you call base.get. Okay, we are taking this is inside HashMap, k.q, k is a reference of q, okay. We still have k as a reference of q, but now q has changed. There is something called equivalent of q. We'll figure that out. It says I should have an equivalent function over key, क्योंकि हमारे HashMap में key थी, and I am passing you a q. So I need to establish equivalence. Okay, get inner. This is fine. I'll create the hash. I am calling table.get. Table is nothing but a huge array or a set of buckets. Equivalent key. Equivalent key is a function which takes a reference of q and returns another function. दिख रहा है ये? Return type is a function. And that function again returns a boolean. So I am saying somewhere when the get operation is happening, call this k.equivalent. Okay, we'll see that. Table.get. You get an eq function. Okay. Self.find. Okay. In the bucket at this index, perform an equivalence. Okay. So now we go back to our equivalence function. K.equivalent x.0. X.0 is again a tuple. And remember, k is a reference of q. Equivalence, okay. Implement equivalent for all q's such that k implements a borrow of q, and this is how we check the equivalence of the keys. That means my HashMap was k, but I gave you a q, which is a reference of k, right? That means reference of q. And k implements a borrow of q, and this is where we check, अरे borrow सच में होता है कि नहीं? Are the two keys equivalent? If yes, then you go ahead and perform match operation on these two keys, or perform an EQ operation on these two keys, one k, other being q. Fair? So if you were to implement your own HashMap, this is what you would also do to ensure users are passing you a reference of q, which avoids heap allocation. ठीक है?